So I put this together so that people can understand what is synchronous flow and what are the necessary and sufficient conditions to establish synchronous flow within a company or within an organization. And it's part of my operational excellence. So I promote operational excellence. And of course, a part of operational excellence is synchronous flow. And so I'm all about necessary and sufficient. So when we talk about necessary and sufficient, what does that mean? So necessary is something that we need in place to achieve some objective. So if we have objectives within our company and goals, then we need the necessary processes in place to achieve those goals. So some companies we work with don't have the necessary elements to be able to achieve their goals. So they're on like, why aren't we able to meet our goal? Right? We're working hard, but like we're not meeting the goal. So do you have the necessary things in place? And then the second piece is it sufficient? So what is sufficiency? Means that we are getting the results that we want. So we got the necessary things in place and they're delivering the results that we're looking for. Okay, so everything we do is about necessary and sufficient. So some companies we see have the necessary things, but it's not delivering the results. Some companies don't have the necessary things. Of course, if we don't have the necessary things, we're not going to get the results. And our first focus is to get stability within the organization. So we'll talk about what that means as we go through the simulation. And it's about synchronizing the flow. So really the objective of today is just understand the effects of traditional manufacturing techniques on the organization. So we're going to go through a mind shift today. So we're just going to do one mind shift today. So at the end, your head should be spinning like, how did that work, right? It doesn't make sense. It's it's non-traditional, right? So to get better results, we got to do something different. So the question is what, right? And our definition of insanity, right? Doing the same things over and over and expecting different results. It's like, well, we're doing the same things, but we're not getting better results. We don't know why. Well, we got to do something different. So the question is what? So we'll learn about that today. So we'll talk about applying these techniques to operations, and we do it through a game called the dice game. So the dice game helps us understand different ways of managing operations and how to integrate those concepts into our own operations to improve our performance. So some of the key learnings, what are the pros and cons of various operations methods? Describe how to synchronize operations to customer demand, create a stable operating system, explain the relationship between optimizing system performance and individual process performance. So I'm all about system performance. So systems thinking is a lot different than what people are used to thinking about because we're thinking about our department or our function. And it's like, right, we got to do the best we can in our function. If we do the best we can in our function, then we're going to have the best results from the company. That's individual function thinking or process thinking, but we got to think about system thinking. So it's a lot different thinking. And so Dr. Goldratt that trained myself and actually Joe Cooper on a lot of the theory of constraints is about systems thinking. And recently I've been studying a lot from a guy called Dr. Russ Akoff, which did a lot of work in the 80s and 90s on systems thinking. So it's quite a bit different than what people are used to. And I have this one video I watched from Dr. Akoff. It was like 15-minute video. And what he said in 15 minutes took me 25 years to understand. It's like, where was he 25 years ago? Right. It's like, if I would have known this 25 years ago, right? It's like, I wouldn't have had to, right, go through all this pain of like understanding why things don't work and why certain things do work. And it's like, so it's systems thinking is the key. So if we look at the competitive landscape, most companies are competing on a global market. So when we're competing on a global market, right, there's more demand for our products and customers want greater variety. They want short lead time. They want high quality. They want fast delivery. They want competitive prices. And companies are competing globally. But what we see is a lot of companies use what we call traditional manufacturing techniques. So why is that? Why do people think that companies continue to do the same things over and over, even though the landscape is changing? Any comments on that? So a lot of times I go into companies, right, and look at the things that they're doing. I'm like, why you do it that way? What's the answer I get? Been doing it that way for 50 years. That's the way we've always done it, right? But what we see is, right, external things are happening and changing, but we're not changing the way we operate. So a lot of companies operate the same way because that's what they know. They feel comfortable doing the things that they know, right? But we know to get better results, we got to do something different. But why do companies, right? That's what we know. So some of the traditional techniques, we have what we call batch and queue processing. So batch and queue processing is we release materials or jobs to the floor in batches, and then we hope that they get processed through the system and come out correct on the right time at the end. And we have policies in place. So the first policy is no one should remain idle. So if someone doesn't have work to do, find work for them to do. The second thing is the larger the batch, the lower the product cost. So if we can release and batch our processes and take advantage of fewer setups or material yields or whatever, right? The larger the batch, the lower the cost. And the third one, to maximize profits, we need to make every operation efficient. So if we go through the operation, we make every step of the process efficient, and we're talking from order receipt to order shipment. So all the administrative steps of taking the order, entering that order, engineering that order, purchasing the stuff for that order. We're talking about all those process steps until we produce it and ship it to the customer, right? The more we can make those process steps efficient, the better we will be as a company. Okay, so these are the traditional thinking that we see. And some of the traditional measurements, we have two traditional measurements. One is utilization. So utilization is the time that the process is working compared to the time available. So if I walk out in the shop and I see a machine, right, is the machine producing something? If not, it's not being utilized. If it's sitting there being set up or not running, it's not being utilized. And so if we have a 10-hour shift and of that 10 hours, 5 hours it's actually producing product or adding value, right, we're 50% utilized. Okay, so what a lot of companies are trying to do is drive up that utilization. So we try to batch work, we pull orders ahead to put like jobs together to try to increase our uptime or utilization. Okay, the next one is efficiency. So efficiency is the actual output against some standard. So if I have a machine that's operating at a certain rate, say 100 pieces per hour, the first hour I get 90 pieces off the process, I'm 90% efficient. So efficiency is in some unit of time. So we have standards, right? How long a process should take. I'm comparing how long it actually took to what the standard says, and that's my efficiency. And so again, we're trying to keep people efficient. So if we don't have work, we'll find work for you so we can generate more. And a lot of the measures I see in companies are standard direct labor hours or more inventory credits or more earned hours or more machine hours, right? So there are all these efficiency measures. And so we're trying to get high utilization and high efficiency, right? We have all this money invested in this equipment and people, keep people working. So can we have high efficiency and low utilization? The answer is yes. So I can work for 1 hour, right, and produce 100 units. So I'm 100% efficient. But that 1 hour of the 10-hour shift, I'm only 10% utilized. Okay. Can I have the opposite where I have high utilization and low efficiency? Yes. So I can run 9 of the 10 hours, right? I'm 90% utilized, but everything I make is scrap, right? I'm 0% efficient, right? So if we make scrap or things aren't conforming, right, that doesn't go against our efficiency. Okay. So you guys probably don't have scrap, but we've seen that in other companies. Okay. And then these traditional measures create undesirable effects for our customers, for operation, and for the business. So I've came up with a generic list of undesirable effects I see in companies. So let's go through the list and see if it applies to anybody that's on the call. So first of all, it has effect on our customer. So it reduces our ability to react to customers' demands. And we typically have long lead times when the customer order comes in. It's like, oh, that's going to be, 8 weeks or 10 weeks or 12 weeks to get that order to you. And then we're not very good at hitting the promise dates we give to them. So we miss the date and then we repromise the date and then we miss it again, then we repromise the date. And after the third time we promise, we ship it. And when we do that, customer loses confidence that we're going to be able to deliver to their need. And then what happens is we actually start to modify their behavior. So whether you know it or not, you and your market is modifying your customer's behavior. So what does that mean, right? So due to your lack of performance, right, they start to compensate for that lack of performance. So the example I give, it's like my wife has this hand cream that she likes. And I usually get it at Walmart. So I go to Walmart, they're out of stock. Okay. Go back a couple days later, out of stock. Go back the third time, oh, there's 4 units in stock. What do? I buy all 4, right? They're modifying my behavior, which shows a peak in demand consumption when it's a false demand signal. Okay. So we don't want to modify our customers' behavior and get false demand signals, right? And that causes chaos in our organization. So it'll be like, oh, I know they never deliver on time, so I'm going to give them an earlier date than what I actually need it. So when the date comes when I need it, it's available, right? So now you're rushing. So we're working with a company right now where they make these big industrial furnaces and they're not very reliable. And they get the furnace done. They call a customer, hey, we got the furnace done. They're like, oh, yeah, we need it in 3 months. Can you hold it for us? Okay, so that's the things that we see where the behavior gets modified from the customer perspective. So now I spent all this time and energy and I got to wait 3 months to deliver it so I can invoice and get paid for it. Anybody feel any of those effects? Okay, then next is the effect on our operation. So it reduces quality, increases chaos, and makes the operation difficult to manage. So if there's rework, right, and there's a problem with quality, then we have a whole bunch of stuff that could be suspect product that we got to rework. Then priorities are constantly changing, so we're constantly expediting and rescheduling. So you go out and force, stop working on that job. This is a hot job, so switch to that job, right? Then 2 days later, oh, nope, that's not the hot job. This is the hot job now, so switch to that job. And then it seems like the bottleneck is wandering throughout the operation. So one day it seems like it's in one department, then it feels like it's in another department, and we're constantly chasing the bottleneck. Okay. Then third is the effect on the business. So a lot of times we have excess inventory. It ties up our cash. We have poor employee relationships. So when we can't meet that demand and we get more orders coming in, it puts more load on people. We are pushed to work harder and work overtime. A lot of times I see mandatory overtime, right? That doesn't go over very well, especially during the summer months, right? Where we're working mandatory overtime on Saturdays and then stress levels increase. Anybody feel any of those effects? Okay, so those are the effects that we see from traditional operations. So if you're feeling any of those effects, right, then let's understand why those negative effects are happening. So the question becomes, what do we change? So how we currently operate causes these issues. What do we change? So we can have a change that can only affect operations, or we could do finance, right, changes. But what we want is both. We want changes that are going to improve our financial and operational performance in a short period of time. And short period of time, we're talking like weeks or months, not years, right? So when we start an initiative, we want to have significant results in weeks, typically. So when we look at implementing improvements, there's 2 approaches to implementing improvements. So the first approach is the cause of all our issues is our variability in our processes, employee skills, vendors. So it's all the problems that happen throughout the day. Right. So what problems are you dealing with? Oh, the supplier delivered late. Oh, we had a quality issue. Oh, somebody didn't show up for work. Oh, we had a machine breakdown, right? Those are all the problems. So we can go out and start attacking all those problems, right? We call it the shotgun approach. And so this approach is comprehensive effort. And if you go through your organization and you ask your employees what are the top 3 things that we need to fix. You ask 10 people, you're going to get a list of 30 items. So which one do we focus on? Like we start working down the list. And we need to do that on top of your daily responsibilities. Okay. So it's very comprehensive and we can expect improvements in a short period of time. Right? If you got years to wait, use this approach. Okay. The second approach is the cause of all our issues is how we operate. Okay. But it takes a lot of courage and consensus to change the way we operate because we've been doing it this way for years and years and years. And people are creatures of habit, right? When we start to get people outside their comfort zone, it's like, I don't like this. Let's go back to the way we did it before. Okay. But if we could provide focus where it's important to reduce variability, we call it the rifle approach, right? Now we're focused in the right areas and we can get significant improvement in a short period of time. And I'm talking, I'm not looking for 5, 6, 7, 8% incremental improvement. I'm looking for 50%, 80%, 200%. We had a company that improved their throughput 300% in like 6 months. It's like, I shouldn't be amazed, but I'm still amazed when I see those types of results, right? It's just mind blowing to me. I think I told David that story. Okay, so question is, what do we change to? So we'll start with the dice game, get an understanding of what to change to. And so there's 5 different rounds we're going to play. So each round we're going to evaluate different approaches to running operations. We're going to evaluate those different approaches and results, raise your awareness of what synchronous flow is about, and then how it might apply in your environment. Okay, so the games to simulate operations environment. So if you have a customer and there's different steps and different resources required to deliver that product or service to the customer, then right, this concept applies to you. So everyone has a die or dice at their workstation. That's your resource, and every day you're going to roll the die and determine what your output is for that day. So every day is like a roll of the die, right? We don't know what the outcome is going to be. So with every operation, there's variation, right? So what is variation? So anybody define it for me? So variation is basically the difference between what we expect and what we actually get from the process. So variation is the cause of all the problems that happen throughout the day. So I expect to get this job completed today. Up, we didn't get it done. Why not? Oh, right, we had a quality issue. Oh, the supplier didn't deliver, right? So all those problems, right, create delays, right? And those delays transfer downstream to the customer. So each process, we need to understand what's the expected outcome, what's the tolerance, and then if we're outside the expected tolerance, right, why is that? And so one of the things I promote is like every step you do is a process, right? So have you defined in your organization for each of those processes what's expected and what's the allowable tolerance? People are like, what are you talking about? I'm like, so purchasing, right? What's the expected, right? What's the normal condition? What's the allowable tolerance? Maintenance, HR, IT, engineering. Right? They're like, what are you talking about? So if there's a process so we can measure it, right? There's an expected outcome and there's an expected tolerance. So a lot of people think about like on a print, right? I have a nominal dimension and a tolerance. What is that tolerance? That's the allowable variation from the customer's perspective. If I don't define that for my processes in the organization, how do I know if things are operating normal? I don't, right? So this is all about understanding what variation is important to focus on, what variation is not important to focus on. And if we focus on the important variation and reduce that, we can get big results for the organization. Okay, so understanding where the biggest disruptions are, they're causing the biggest disruptions to the organization as part of this process. Because we all know that stuff happens, right? So overview of the game. Raw materials we get from our suppliers, we get it on consignment. So we get invoice from the customer once we release it to production. As long as we don't release it to production, we don't have to pay for it. As the product moves through the different steps, we add value, and then the final product shipped to the customer. Okay. There's multiple steps in the process, so each of you will be playing a role as one of these steps in the process. And we release work from consignment into the process, right? We process it through based on what our dice roll is. That next person, right, takes that. There's work in process between each step. That next person takes that work in process. They process it through, right? And everyone works together every day. We're rolling together, entering our data, and the product's moving through the system. And then hopefully it gets out on time and we ship it to the customer. Okay, so we only have one rule. So the spreadsheet's set up so you can't break the rule. You can only process the maximum or the minimum of what you have available or what your resource produces. So if I have 4 units and I roll a 2, I can only move 2 because that's what my process produced. Or if I have 4 units, I roll a 6, I can only move 4 because that's all the material I had available. Okay, so you can only move the lesser of what you roll or what you have available at the start of the day. But you don't really have to worry because it's built into the spreadsheet. You can't move more than what you have available. Okay, so we're going to run 5 different rounds, 2 using what we call balanced capacity and 3 using unbalanced capacity. Each round will consist of 20 working days, and we have a demand of 70 units per month. So if we need to get 20 units out in 70 days, what's our average daily output? So we take 70 divided by 20, it's 3.5. So on average, we need to get 3.5 units completed each day. Okay. Each roll represents 1 day's output. The work in process represents the orders in the system. Everyone rolls together and enters their data together. And then again, you can only move the lesser of what you roll or what you have at the start of the day. So first question is, do we have enough demand? Enough capacity to meet our demand, right? So our demand's 70 units. We're going to start out with 1 die in each step, right? Anybody know what the expected value of a single die roll is? So you can take all the sides of the die, add them up, divide by 6. It's 3.5. So expected outcome of a single die roll is 3.5. Can we roll a 3.5? No. So every roll there's variation, just like reality. We never get exactly what we expect. Okay. So our goal is to make money, create a secure environment for employees, and satisfy the customer. So these are 3 of the requirements of any organization. So make a profit, as long as you're a for-profit organization, right? Make sure you have a secure environment for employees so that they're not nervous that the company's going to go out of business, and we need to satisfy the customer. Okay. So that's our pot of gold. Okay, so let's start with the simulation. So we'll start with round 1. I might have to change this up a little bit. I can step in and take a couple. So does everyone have access to the spreadsheet? Everybody
There's
see
a
that?
link in the chat if you either didn't see it in the email or haven't clicked on it. I did put it in the chat for everybody.
So who am I missing? We got Roy, Samantha, Joe, David, Danielle, Diane, Aaron's here. So we're missing. So I'll do shipping. Joe, can you run 2? Or David, can you do 2 worksheets, Joe, or no?
Sure.
So you can have it open up twice and you can just put in. Okay, so if you see the spreadsheet, if you open up, you'll be on this tab. You look at your name in the list here and click on your operator. So like Samantha, you're going to click on operator 2 down here at the bottom, and this will be what view you have. Everyone needs to go to their operator view. Everyone on their operator view tab.
Yep.
Okay, so when I signal, I'll roll the dice for everybody. Everyone see the die on their screen.
Yep.
So we're going to be on round 1, day 1. So where this actual roll is here on your spreadsheet, that's where you're going to be entering your data for day 1. So I'll facilitate, I'll roll whatever comes up on your die. You're going to enter it in for day 1. Then we'll move to day 2 and so forth. And sometimes when I say the roll's complete, the dice won't change. That means you rolled the same number again. Okay. So sometimes you'll see it not change. So let me run a sample. Everyone's on their page, correct?
Yes.
Okay, so I'm going to do a sample run here. Second, I'm going to keep the operator tab up here. So everyone see the company view on their screen. So you can see all the operators and you can see the inventory in the system. So everyone has a starting inventory of 4. So I just took 3.5 and rounded it up to 4. So you'll see your process and we'll monitor this every day on how people are doing, entering their data. Okay, so I'm just going to do a sample roll here. Okay, did everyone see their dice change?
Yep.
Okay. So everybody's good. So let's start out day 1. We'll sort of start slow, make sure everyone's got the hang of it. So I'm going to roll for day 1. Okay, so day 1 roll is done. So enter your results in day 1 actual roll. And you guys are good. Everybody's on, so that you can see where everyone is on day 2. Okay. Okay, day 2, I'm rolling. Okay, enter day 2. Okay, and you can see the inventory profile change, right? So Dave, you got to pick it up a little bit.
What else is new?
Also, I see Diane's like struggle a little bit, right? So Samantha's doing a good job. So good job, Samantha. Keep moving stuff to your station. Okay. Okay, day 3, I'm rolling. Okay, day 3 is done. Okay, day 4, I'm rolling. Okay, day 4 is done. Okay, day 5, I'm rolling. 5 is done. Okay, so how are we doing on the flow? So still a little bit backed up here in the front end. Samantha, Dave's still backed up. Okay, so everyone
Somebody
work a little
better
bit
give me some more training here.
work a little bit harder.
That must be it.
Okay, I'm rolling for day 6, so day 6 should be done. Okay, day 7. Day 7 is done. We need to have a talk with Danielle and Dave again. Okay, day 8. Day 8 is complete. You guys are good. Okay, rolling day 9. Day 9 is complete. Okay, day 10. I'm rolling day 10. 10 is complete. Okay, so we're halfway through. Demand the 70, we should have shipped 35, so we only shipped 31. So can we work a little bit harder the second half of the month? So like let's pick it up just a little bit. We're not too far off, but I don't see a lot here in the last 3 processes. So come on, guys, up front, let's get it moving. Oh, Diane. Okay, rolling day 11. So day 11's in. Okay, day 12. Day 12 is done. Okay, day 13. Day 13 is done. Okay, day 14. Day 14 is done. Okay, rolling 15. Okay, day 15's done. Okay, rolling 16. 16's done. Okay, 17. 17's done. Okay, 18. 18's done. Okay, 19. 19's done. Okay, last day of the month. Need good rolls here. Last day, day 20. Okay, 20's done. Okay, so you can see your efficiency on the screen here. So Roy, you did great, 108%. Right, Samantha, 94, Dave, 85. Okay, so everyone see their efficiency. Okay, so let's talk about our performance. So we'll talk about what performance metrics we're going to look at. So the performance metrics we look at are 3 financial and 4 operational. So from a financial perspective, it's our throughput, which is a measure of our value added. Our operating expense, which how much we spend to create our throughput, and our net profit, which is our throughput minus our operating expense. Then we have our operational ones, which is our inventory. So how much inventory do we have tied up in our system? What's our delivery performance? What's our production lead time? And then what's our productivity? So I'll talk about these each individually. So throughputs, the rate we generate money through sales. Okay. So it's a measure of the value added. It's the difference between what we sell the product for and the price we pay for materials to make the products or outside process. So if we make something, we sell it for $100, it costs us $30 to buy the materials and $5 to outsource a step in the process, right? That's $35 for that outside processing that our suppliers are adding value. So our difference between that cost and our selling price, in this case, $100 minus the 35, right? Our throughput's $65. So each time we ship that unit, we get $65 of throughput. So we take the selling price minus the what we call the totally variable cost times our quantity shipped, and that's our throughput. So in this simulation, we sell each unit for $500. It costs us $200 to buy the materials for that. So our throughput is 500 minus 200 or $300 per unit. Okay. So if Roy releases 4 units into production, how much throughput do we generate? A lot of people say, oh, 4 times 300, $1,200. No, the answer is 0. Why is it 0? Because we didn't ship it. It's through sales. We get revenue when we ship, not when we release into production. Okay. Next is operating expense. So this is all the money we spend to turn inventory into throughput. So it's all the costs that run the business, our direct labor, indirect labor, our insurance, utilities, taxes, lease and rent payments, salaries, tooling expense, right? Toilet paper, safety glasses, everything to keep the doors open. So in our simulation, it's $18,000 a month, right? That's basically if you stop producing stuff, how much expense would you have just to keep operations going? Okay. Then our net profit, of course, is that throughput minus the operating expense. Then our inventory is the money we spend on things we intend to turn into throughput. So we don't add value to the inventory. We keep it at the purchase price because I want to understand how much cash I have tied up in materials, right? So the inventory that we purchase for cash, we want to understand where's that cash in our system and how much cash have we got tied up in our system. So we take the work in process, and because we got consignment materials to make it simpler, we don't consider our raw material because that's consignment. So it's everything we have in process times $200 per unit. That gives us our work in process. Okay. Then our customer service is what we ship versus what we promise. Our lead time is a two-step calculation. So we calculate how many units we have in inventory divided by our actual daily rate. That gives us our lead time. So we take our number of units shipped divided by 20. That tells us our average daily rate. We divide that into the number of units in process, and that tells us our production lead time. Then our productivity is the true measure of plant productivity. What's the throughput that we generated for the period? How much did it cost us to generate that throughput? So that ratio is our productivity measure. Okay, any questions on those metrics?
I'm really glad this is going to be posted so we can go back and look at it again.
Yeah, so this is part of the mind shift, right, on how we look at our performance. It's non-traditional, right? A lot of people allocate labor to the material, right? Then we have value as it goes through the process, and then we have a margin on jobs. We look at it from a different perspective. Okay, so let's look at our performance. Let me calculate the performance here. Magically appear. Okay. Everyone see that performance on the screen?
Yep.
So we should have shipped 70. So I look at total our supporting metrics. We only shipped 54 of the 70. We had 58 units in process. So based on that 54 shipment times the 500 minus our material cost for that. So 54 times 300 is 16,200. Right? That's our value added. Our operating expense was 18,000. So we lost 1,800 bucks. I mean, I don't know why these inventory numbers aren't showing up. Hang on a second. I'm just going to change the color.
Is it that right in the middle there, the
Where is it? Oh,
paint
right
can't
there.
right there. Yeah, oh yeah.
There we go. So then our inventory was 11,600. So we did a good job of getting stuff in the operations. We didn't do a good job of getting it out. So our due date performance is 77%. Our lead time is 21 and a half days, and our productivity is 0.9. So someone needs to explain to me why we didn't meet the demand and we lost some money. Not my fault. Fault the manufacturing coat of arms. Not me. It's everybody else. Everybody explain to me why I had to go to the bank and do a draw on our line of credit, keep the doors open.
I did get a lot of low rolls in there.
So Diane's admitting that she didn't do so well.
The reason you had to go to the bank and get a line of credit is because you had too much debt to begin with.
Yeah, we didn't have any cash at the beginning, right? And we drained more cash. So when you look at this, it's really hard to determine like what was the cause of this issue, right? And these are sort of our KPIs, these top 7, and then we have our supporting metrics. So I know we didn't ship enough. We did a good job getting stuff in, right? So we only started with 36 units in production. We ended up with 58. So we almost doubled the amount of work going into the system, but we didn't get it out. Everyone see that? So I know the beginning inventory was 36 units. So that was part of the drain on our cash. And the other drain is we didn't make a profit, right? We lost money. Okay, so let's look at this. So this is what we call a balanced system where everyone has the same capacity. So everyone has a single die. The multiple times I've run this simulation, nobody's ever hit the target of 70. So you guys were 58, right? So you're about right here. So right on average. Okay. So why is that? So when we look at balanced capacity, it rarely produces the results that we're trying to achieve. So why? In most cases, what happens is delays transfer downstream. So when someone has a bad roll, what happens? That transfers to the next operation. Okay, so in a balanced system, delays transfer downstream, and typically all the way to the customer. But there's another phenomenon that happens. Gains never transfer. So why don't gains transfer? So let's just say Roy rolls a 6, right? Releases 6 units in. What's got to happen to ship 6? Everybody has to roll a 6. What's the chance of that? Slim to none. So our general rule of thumb is the more steps in the process or the more variability in the process, the less the outcome. So why is that? Because every system has variation and every system has dependencies. Right? So each person is dependent on the person in front of them. So if the person in front of you has a bad day, right? I'm going to have a bad day because I don't have the stuff to work on. And I see companies like, oh, we're going to run Saturday in these 2 departments, and they come in Monday. There's nothing to work on. So I stand around Monday doing nothing because I'm out of material. Right? That gain that we just had on Saturday is lost on Monday because we're not able to produce. Right? So every system has variation, every system has dependencies. The greater the variation, the greater dependencies. So how many steps in the process, the lower the expected result. So if we added 5 more people to the simulation, we're not going to get 54. Or we're going to get something less than that. Okay, so what do companies do when they don't meet the expected result? They run overtime. So let's look at people's efficiencies in that round, just to do a quick. So what do we see with the efficiency? All right, we started out good. We didn't end so well. So as we see the efficiencies through the system, what do we see? It's dropping, right? So each person delays transfer. So if you look at your actual rolls, how many times couldn't you process everything that you rolled? So I know Roy's 0, right? Everything he rolled, he was able to release. If you count how many times you had less of the orders processed compared to what you rolled is, that's the delay that's happening from the previous step. So I have 1, 2, 3, 4, 5, 6, 7, 8. I got 8 cases where I couldn't produce what I rolled. So I was starved. Half the time I was starved for work. I'd expect most people upstream from me have less than that, right? Because delays transfer, gains never transfer. Okay. That's why we see the efficiency drop. Now, some companies be like, oh, right, we can prevent the dependency. Let's just flood the system with inventory. So what's the implications of doing that? So what we see, lead time goes up, quality issues go up, due date performance goes down. So the solution isn't to put more jobs on the floor. So round 2, we're going to allow you to run overtime. Okay, so you as a team can decide, like if someone wants to run overtime, what you're going to do is you're going to add, I'm going to roll a dice for you a second time, and you're going to put that into your spreadsheet. So let me change the parameters here. Any questions on round 1? Okay, so the board's cleared. Now you see in round 2, you see a gray column that says overtime. So if you decide as a team someone wants to run overtime, I'll roll a second time, and that one person will put their overtime into this gray column. I'm only going to give you 5 overtime units for the 20 days. So not every person gets five total between all 10 of us. Okay, so I usually tell people I can give you a hint. I can give you 0 hints, I can give you 1 hint, or I can give you 2 hints. Anybody want hints?
I think
Might
you
as
should
well
give
get
some
one.
hints, Max.
What's that?
I said I think you should give some hints.
Okay.
Help us out.
Okay, hint number 1. I'll go back to round 1. What did we just learn about delays? They transfer downstream. So running overtime early up here in the process, chance of that getting the shipping, you're wasting your money. The second thing is when we're looking to run overtime, we don't look upstream in our process, we look downstream. Why is that important? So you could say, oh, Samantha's got all this work, right? She should run overtime. No, you look downstream. Joe's got plenty of work. Don't waste Samantha's overtime to put a bigger pile in front of Joe. So most companies look upstream, be like, oh, we're piled up. No, you need to look downstream. So who would be a candidate to run overtime here? If we look downstream, potentially Dave, but he's early in the process. My best candidate would be Diane, right? I want to get this pile moved down because she's going to starve Aaron. So I want to, the later in the process, the higher the priority. As I get further up in the process, less priority. And I look downstream to see what work is piled up in front of the downstream resource before I determine to run overtime. Does that make sense to people? But if I don't have visual management and I can't see how much work is piled up in front, it's just we're guessing blind.
Is the overtime only dedicated to one area here?
Nope, anybody can run it.
Okay, so when you're talking about as a group deciding to run overtime, is it for all 10 stations
Yep.
or is it just for one station?
Nope, all 10. So we can say, do we want to run overtime? We have a discussion. Yeah, we should. Maybe Diane's the best candidate to run overtime. Let her run overtime. So we're deciding as a group where we run the overtime.
So the goal here is to meet the date, the due date for the products going out the door.
Yep. Still the same date.
Okay.
Still the same goal. Make money and ship on time.
Well, you're going to meet the due date for the quantity of products going out the door, but does that also mean you end up with excess product?
It does if you run overtime in the front end. So if we're releasing work to keep people busy, so I've seen companies like, oh, this guy's out of work, right? So find a job for him and let's release another job. Well, in this scenario, why would I do that when Samantha's already overloaded? We call it sub-optimization. So I'm trying to keep you busy, Roy, at the expense of, right, excess inventory in the system.
But we as a group will decide
Yep.
which station, because only one station on any day will run overtime.
No,
But it can be
you
any of
could
them.
have all 5 people run day 1 and be done.
Oh, okay.
So you could say, okay, Diane and Dave and Tina are all going to run overtime today, and that's 3 of your 5 units.
Gotcha. Okay.
So I limit it so you have to be diligent about making the decision. Okay, any questions on this round? So we're all clear. So same rules before. You're just going to decide as a team if you want to run overtime. If you want me to voice my opinion, I will. Otherwise, I'll keep quiet. Okay, everybody ready? Okay, so I'm rolling day 1. So day 1's complete. someone feels like they need overtime, just speak up. Okay, day 2, I'm rolling. Day 2 is complete. Everyone good? Day 3, I'm rolling day 3. Day 3 is complete. Wait, yep, now it's complete. So where's potential candidates in this round for overtime? We just look at the data.
Me.
Yep, Diane potentially, and also me, right? So we got 6. My expected value is 3.5. I'd let it roll one more day, see what happens, is my opinion. We'll have a talking to with Diane, and maybe she'll pick up her performance. Okay, day 4. I'm rolling day 4. Day 4 is complete. Everybody okay? Day 5, rolling. Day 5 is complete. See, I knew Diane would pick it up if we talked to her. Any
Dave, you're
candidates?
gonna make me stand around all day if you don't hurry up.
Right. So Dave would be a candidate here, but he's early in the process. I'd be the only other candidate. Roll one more day, so we'll go day 6. So day 6 is complete. I forgot to say each unit of overtime costs us $150. So it's not free. Are we good?
Or should Dave get some overtime?
What do we think? We're gonna have Dave roll,
I'm really struggling.
or should we have
Why
a
not?
talk to first?
One
So
one time.
I think Dave's nursing it to get overtime is what I think. That doesn't happen, right? Where people slow down to get overtime.
Yeah, it seems like he probably should get overtime.
Okay, so I'm gonna roll again just for Dave. So Dave, you'll enter your overtime into day 6 in that gray area. So
Yep.
okay, so this
Roll
is just for
6.
Dave. So Dave, enter your in your.
Pretty brutal.
What'd you roll?
A 2. Not much help.
We're always productive on overtime, right?
I was really tired.
So that didn't help a lot. So now you see on your operator sheet it says days overtime. There should be a number there, so everyone should see 1 on your sheet. Okay, I'm rolling day 7 for everybody now. You did a little better there, right, Dave?
A little bit. I'm coming around.
Okay. Elsewhere, we're like, so right now, I wouldn't, right? Doesn't make sense to have Dave run because Danielle's got plenty of work, right? Maybe Danielle because Diane's light, but we don't want to get in the point where we're chasing the bottleneck right down the system. So let's let it roll one more day, see what happens. I'm rolling day 8 right now. So day 8's complete. Okay, I would be a candidate for overtime right now. Right, because I have almost 3 days in front of me. So you want me to run overtime?
Sure.
Okay, so I'm just gonna roll here for myself, run overtime. Oh, that was a good one, 5. That helped. Okay. Since nobody else, I'm rolling day 9 right now, so day 9 is complete. So Joe 2 would be the candidate. Let's go and let it roll one more day. What people think. We got 3 days left.
Joe 2 got ones back to back, so
So the probability of getting that again is low, right? Let's go one more day, see what happens. So I'm rolling day 10 right now. Okay, day 10 is complete. Got a whopping 2 that time, Joe.
Yep.
So we're doing worse than we did last round. We're at 28. And we're halfway through. And we've used 2 units of overtime. What do people think? Go another day?
Yep.
Okay, I'm rolling day 11.
two again.
So I think now it's time to have Joe run overtime. Joe 2. What do we think? Okay.
Yep.
I'm
Sounds
rolling right
good.
now just for Joe. So Joe, enter that into your round 2 overtime for day 11.
Did it go?
I don't see it.
Yeah, I just
Did
added
you
a
do
3.
Joe? Did you do Joe 2 or did you do Joe 1?
Oh, good eye, good eye. I thought I was being careful there. Good eye. Thank you.
There we go.
Oh, but I'm looking at the wrong die now. So let me change that. There we go. I'm working multiple workstations here.
Need another screen, Joe.
Yeah, I've got 2. I need 3.
A mission control over there.
Oh, that was a good roll.
Yeah.
You're not milking it to get overtime, are you? Okay, we're a little bit better shape. So I move into day 13. Wait,
But I think
day 12, right?
day 12.
Everyone enter day 12. Yes, we're not looking too bad right now. Let's go one more day, day 13. We still have 2 days overtime left. That's a good roll. So Aaron's got a little bit of a problem here. So should we let it roll one day, or we want to have Aaron run overtime? We got 2 left. We let it roll one more day.
Yeah, let's roll one more day.
Okay. So day 14 I'm rolling right now. So 14 is done. Yeah, I think we need to have Aaron run overtime now.
Yeah, I think I need to run some overtime. Got a 1 and then a 2.
Okay, so I'm gonna roll just one more time just for you. So enter it into your round 2 overtime. Okay, so the roll's
Ooh,
complete.
that's a good one.
Oh, he crushed it. Good job, Aaron. Okay, now we're moving to day 15, correct? Yep.
Yes.
So we also have what we call a point of no return, right? So right now we're day 16. So what's in front of me is 16. What's in front of Tina's 17. What's in front of Joe's 18. What's in front of Aaron's 19. What's in front of Diane's 20. So the point of no return is what's in front of Diane. Right. So I wouldn't run any overtime because their expected value is 3.5. So hopefully she'll flush that out. But anything up front from Danielle isn't going to make it. So as we get closer to the end of the month, that point of no return gets smaller and smaller. Okay, so I'm
In a
gonna
tip,
what's that, Dave?
I was just going to add, back to your previous point, like in a typical scenario, right? Lots of companies would be looking at this and saying like, hey, let's run some OT on the hopes that it made it through the system, right?
Yep. So like they'd feel pressure to run Joe, right? Because he's piled up, there's nothing here, but
Yep.
like it's not gonna help us this month. Might help us next month. Maybe, right? Because we know
Maybe.
that gain's gonna get wasted someplace. Okay, day 16, I'm rolling. 16's complete. Good job, Diane. So we're set up for success here. Now I just gotta execute. Okay, day 17, I'm rolling. 17's complete. But that wasn't a good roll for me. We're all set up for success and I ruined it. So should I run overtime right now? So we only got, or should we have, see, we're day 20, 19, 18. So what's in front of Joe Cooper 2 is our last point of no return. So we could have Aaron run overtime. If we don't get that 7 moved, we're not going to make it.
Seems like
Yeah.
a good choice.
So I'm going to roll again for Aaron run overtime. I'll let mine roll and then we can run overtime on the last day if we need to. So I'm rolling now just for Aaron.
Aren't we already at 4 overtime days though? We only have one left.
We just used it. I thought we had 3.
Got another
do we-
6 out of me though.
No, we just need good rolls for Okay, day 18. I'm rolling 18 for everybody. Okay, 19, rolling 19. Oh, a couple good rolls. Need one more good one.
There you go.
Wish we had that one day overtime. Okay, day 20. I'm rolling day 20. Oh, that wasn't good. Okay, so let's look at our performance this round. So we lost more money from the financials, so our profit went down. We shipped 2 more units, so we got more throughput, but we used 5 overtime units to do that. So our operating expense went up by 750, so we lost more money. Our inventory went down slightly. Our lead time came down a day and a half. And so my daughter would say, we got good news and bad news. The bad news is we're losing money. The good news is we're losing it at a slower rate. So what happened that round? We tried to use our overtime to improve our performance. Not much difference, so a lot of effort for not much gain. So we did take a little bit of inventory out of work in process, which reduced our cash negative position, but still losing money.
So I didn't think about it until after it had already happened. But so one of our overtime days that we used um, for max, Tina only had one available to output. So though you had 13, I think we could have gone another day to get a second roll without using the overtime on that and using
Yeah,
it later on.
probably. Yeah, so we didn't use our overtime quite right. Right, so overtime, right, you got to really understand from the system perspective what's the best use of your resources. Just don't throw overtime blindly at operations, because most of the time you're just going to waste it. Okay, so what happens with overtime? So these are our rules that we didn't cover. Our performance. So overtime helps, but it can be expensive. It has diminishing returns, meaning the more that we do, the less we get. So if we are working more and more overtime, right, we start to see output reduce. It's usually reactive, so we're working based on the piles. It can create more dependency. So again, if we work in one department, not other departments, then we starve the department, so they come in the next day, nothing to work on. We just lost all that gain we had. It adds the chaos. Okay, so now we're going to go to round 3, which is unbalanced. So from the balanced capacity, one of the things that we learned, right? In a balanced system, delays transfer, gains never do. If we don't utilize out overtime correctly, right, it can have a negative effect. Okay, so can we take like 10-minute break? So we'll come back. I got 5 minutes to 2 Eastern time. So can we come back at 10 after? We'll do round 3, which is unbalanced.
Sounds good.
You want to come back at 10 after?
You have everybody back?
Yep.
Yep, we're here.
I'm back.
Okay. Aaron, you there? Okay, let's continue. So the first two rounds were balanced capacity. Now we're going to go to unbalanced capacity. So unbalanced capacity is everyone has different capacities. So that's typically what we see in companies because different functions or different operations work different. Might work different shifts, might have different machines in each department, have different rates on processes, right? So most companies are what we call unbalanced, right? So now round three, I'm going to unbalance the process so everyone's going to have different capacities. So some people have two regular dice, some will have two with dice that's limited on what they can roll, and some people will have one. Okay, so in this situation, with the unbalance, what do we think is going to happen to our performance? So are we going to get more out the door? Sure hope so. So let's look at our performance metrics that we had. So if we unbalance the capacity, give some people more capacity, what do we think is going to happen to our financials? Are we going to get more out the door? It's a good question, we hope, right? So no overtime this round since we operated so poorly with our overtime last round. So what about inventory? What's going to happen to inventory? So if inventory goes up, right, and our throughput doesn't go up, our lead time is going to go up. And our cash is going to go down. So the keys to this round, there's like, what's the output going to do? What's the inventory going to do? Right? Because those two variables will affect the other measurements. Okay, so now you should see on your screen either multiple dice or a single die. Everyone see that on their operation. Okay, so this round, all rules are the same, no overtime. You're just going to add in the round three axle roll, the sum of the two die if you have two die, or the single die value for each day. And then we'll see what the outcome is. Okay, so I'm rolling day one. Okay, so day one's complete. Okay. Day two is complete. Okay, day three roll is complete. Okay, day four is complete. Okay, five. Day five is complete. We need to speak with Samantha. Okay, I'm rolling day six. Day six is complete. Okay, day 7, rolling day 7. Day 7's complete. Okay, day 8. Day 8 is complete. Okay, rolling day 9. Day 9's complete. Okay, rolling day 10. Day 10's complete. So we're halfway through. We should be at 35. So we're right at 35. So we're right on schedule now. Okay. Got quite a bit of inventory in the system. So let's keep going. Day 11. Rolling day 11. Day 11's complete. Okay, day 12. Day 12 is complete. Okay, day 13. 13's complete. Day 14. 14's complete. Okay, rolling 15. 15's complete. Okay, rolling 16. 16's complete. Okay, 17. We need to speak with Danielle. Okay, rolling 18. 18's complete. Okay, 19. Danielle, are you adding your 2 die together?
I don't see that I have to, unless I missed my whole,
You
I'm
got-
on a little screen. Oh, crud. Nope, I'm not.
Wonder why
Dang
you're
it.
so-
Sorry, guys.
It's okay.
We found the bottleneck.
Yeah, sorry. It's the amateur in the room. Sorry.
I don't know if there's a way to tell like what you rolled in past. I don't think there is.
Sorry.
So big rolls for die for day. Wait, I got enter in 19. Hang on 1 second. Okay, last day 20. Okay, so let's look at our results. Okay, so we did a little bit better on our financial metrics. So our throughput went to 19.8 because we shipped 66 versus the 56. So we got 10 more out the door, but our inventory went up significantly. So our operating expense is 18,000. So we actually made money from the profit perspective, but our inventory went up, our due date performance went up, our lead time went up, our productivity went up, but our cash went down. So we consumed more cash, even though we made money that round. So again, we got to do another draw on our line, pay our bills. Okay, so what happened that round?
Well, it might have been even better if I would have had the both dice. So maybe that probably skewed the perspective.
Yep, maybe. Maybe not.
Yeah, I cleared my whip every single time.
Okay, so we did our performance review. So when we have unbalanced, what we see is that it helps with some metrics, but some it doesn't. So inventory goals start to go out of control, right? We saw that. Lead time gets extended. We saw the lead time go up. Cash becomes more of a problem. Quality becomes more of a problem. So why is quality more of an issue when the work in process goes up? Because we see a couple effects, right? People feel rushed, right? So it's like I got all this work in front of me, so I rush and I make mistakes. Or if I have a suspect product and I got all this work in process and somebody didn't do something correctly, then especially if we had like in front of Danielle, right? If the person in front of Danielle had a problem, like Dave, if he had a problem, right, all this stuff in front of Danielle is suspect now. So now we got to go through and sort, like look for defects. And when we do inspection-based quality, we know it's only about 80% effective. So defects are still going to get through the system. Results of our decision-making aren't known, so we're chasing problems. So what's our lesson? So first lesson is don't try to balance capacity, right? So we tried in the first 2 rounds. Doing so will not achieve the results. Don't try to reduce capacity by cutting costs. So we'll talk about the chain analogy here. The goal isn't to make the chain lighter. The goal is to make the chain stronger. Instead, unbalance the capacity proactively and synchronize the flow and create what we call balance flow. So don't get balanced capacity confused with balance flow. Balanced capacity, whereas we're trying to make everybody work at the same rate, right? We have capacity equal in all departments. Balance flow is the time from start to finish of that order is highly predictable. So what we want is balance flow, but we need to synchronize the flow. So let's talk about how we do that. So let's talk about understanding flow first of all. So there's only 3 flows in any organization. So the first flow is we have our suppliers, we have our value-added steps and our customers, and then we have information that flows from our customers through our organization back to our suppliers. So we get purchase orders from our customers. That information comes in our organization where we create the production orders and so forth. Then that information is transferred back to suppliers where we order material. Okay, so our second flow is the value-added flow. So that goes from our suppliers through our organization to our customers. Then our third flow is the almighty cash flow. So cash flow flows at the same direction as information from our customers through us to our suppliers. So if we want to increase cash flow long term, the only way to do it is either increase the information flow or increase the value added flow. Our approach is let's increase both. If we increase the information flow and we increase the value added flow, we're going to increase the cash flow. Okay, so we're looking for sustainable cash flow improvement. So if we look at the activities within the organization, we have activities that transform the product or service one step closer to what the customer is demanding. And then we have activities that don't transform. And so what poor flow looks like is this, right? So we release work, we do a small activity that sits waiting for the next activity. then we do some more work, then it sits waiting for the next activity, and it sits, and then it sort of makes its way through the system and comes out at the end. So the example I like to use, everyone's experience, is going to the doctor's office. Right? So what happens when you go to the doctor's office? You show up, you wait in queue to check in, right? You go to the check-in counter, they take my ID and my insurance card, right? Make all information's correct. So I get 2 minutes of value added. They say, okay, go sit in the waiting room. So I go sit in the waiting room. 40 minutes later, hey, come on back to the exam room, right? So then the nurse takes me and says, okay, takes my blood pressure and my temperature and my weight, puts me in the exam room, says the doctor will be right in. So I probably should change this. So then 40 minutes later, doctor comes in, does 8 minutes with me, right? Says, oh, I probably should get some blood tests. So go sit in queue to get your blood drawn, right? 2 minutes to draw my blood and I'm out. So my total duration in the system's like an hour and a half, and I have like 12 minutes of value added. Right? Everyone's experienced that. And the goal, right, isn't to reduce the value add, right? So it's like a lot of companies are focused on this value added piece. It's like, well, if the doctor spent 4 minutes with you instead of 8 minutes, that'll be better, right? That's more efficient. No, from my perspective, it's the queue time is the problem, not the value added time. I don't want to reduce the value added time. I want to reduce the queue time. So what does good flow look like? I want to come in, check in, go right back to the exam room, have the doctor come in, do his analysis, get my blood work, and I come out, right? So the touch time doesn't change, but my time in the system maybe is 35 minutes for 12 minutes of touch time.
Blood pressure improves too.
So my wife actually took a stopwatch to the doctor. She was there like hour and 45 minutes. It was 12 minutes of touch time. Right. So the opportunities here in the queue time, not in the touch time. But a lot of companies are trying to reduce the touch time. So why are they focused on trying to reduce the touch time? So what we see is that a lot of people price their products based on the labor content. And the belief is if I reduce the labor content, right, it reduces my cost. If it reduces my cost, I'm going to make more profit. Really? Okay, so they think that if reducing the touch time, because we allocate costs based on labor or machine time, that it's going to reduce our cost. But in reality, most of our costs are fixed in the short horizon. Okay, so that's one of the mind shifts is like, no, we don't really want to focus on allocating costs to our time, right? Because it distorts our decision making. So what should we be looking at? So if we look at synchronous flow, we have effectiveness and efficiency. So I'm about a system effectiveness, not about efficiency. So what's the difference? So our goal is to flow work to the customer demand rate. And I like to use a rowing crew as the example. Okay, so this rowing crew on top, they're all rowing in sync, right? Everybody's in sync rowing together. So when everyone's in sync rowing together, what happens? The boat goes in a straight line, right? The shortest distance between 2 points is a straight line. The second rowing crew, the second rower is 3 times more efficient than the rest of the team. What happens to the boat? It's like, great, he's super efficient, but the boat goes off course. And to get the boat back on course, what has to happen? The other 3 rowers got to do extra effort to get it back on course. So by him being efficient, it kills the efficiency of the team. So this is an important concept to understand. So how do rowing teams stay in sync? Anybody know? So some teams have a coxswain, it's called, right? He sits at the front of the boat and he keeps everybody in pace, right? Keeps everybody rowing at the same pace. So from a lean perspective, that guy would be 100% waste because he doesn't add any value. He's not rowing the boat, right? Or the other example I like to use, so we just posted on LinkedIn, a symphony orchestra. Right? So how's a symphony orchestra stay in sync? The conductor, right, keeps everybody in sync. The goal isn't to play through your music as fast as possible. Right? If you're trying to play through your music as fast as possible, that's like a fourth grade band concert. If anyone's ever experienced that. Everybody's out of sync. They're playing it right. But the goal is to stay in sync. So actually, Dr. Deming, developed total quality management. So we had a quote. Joe, do you remember exactly what the quote was?
Not off the top of my head, but basically, a symphony orchestra is so inefficient, and it's his humor, basically speaking, that you know, some people take rest in between. They shouldn't be taking rest. They should be playing straight through. Some people even soften down a bit. They should be playing loudly. It's, the conductor is the only one that works all the way through. So inefficient a symphony orchestra is.
And if you look
Basically.
at the conductor by lean definition, he's still 100% waste because he's not playing an instrument.
Mm-hmm.
Right? So these two situations where synchronization's key, right? How do they keep in sync? They have somebody synchronizing them, right? So that person that's synchronizing them is so critical. So we look at it from a different perspective. It's like the person that's setting the pace for the whole crew or for the symphony orchestra is so critical to keeping things synchronized. So that's part of our synchronous flow concept. So now if we look at the chain, so we have a physical chain here. Most organizations act like a physical chain. So the physical chain, we have different links, right? Each of those links have dependency. So the second link here is dependent on the first link and so forth. And each link has capacity. So just like in operations, right? I got my sales department, I got my order entry, I got my engineering, I got my purchasing, I got my operations, my packaging and logistics, right? So I have all these different functions. Each of those links has cost. Each of those links have capacity. So if I look at measuring the chain, I can measure it two ways. The first is by its weight. So how do I determine the weight of the chain? So if I know the weight of each link, how do I determine the weight of the chain? I add them up, right? Weight acts like cost in a company. It follows the additive rule. I take the cost of each function. If I know the cost, I add them up. That's my cost to run the business. I can also measure the chain by its strength. So how do we determine the strength of the chain? So the strength is our capacity, our ability to generate throughput. So how many weakest links in a chain? So if I look at the capacity, right, that link right there of 950 pounds determines the capacity of the chain. So chain's determined by the weakest link. How many weakest links in an organization? One. So the weakest link determines the pace at which we can generate throughput. Questions on that? So if we look at capacity in organizations, there's two types of capacity. The first one is what we call productive capacity. That's the capacity to produce what is sold. So it's determined by the resource with the least amount of capacity in the system. So we call our capacity constraint resource, our flow dictator, our pacemaker operation, our tax setters. There's all types of terms out there, but it's the resource with the least amount of capacity. If I have multiple independent value streams, right, I might have multiple capacity constraints. But if you have dependent resources where resources are doing shared value stream work, then typically there's only one capacity constrained resource. Then I have protective capacity. So protective capacity is the capacity that everyone has above our weakest link, right? So in this picture here, operation 4 is our least amount of capacity. Everyone else has more capacity. So operation 4 determines our productive capacity. Most people have more than that, so they have protective capacity. So a system can't operate with zero protective capacity. That's a balanced system. That's what we did the first 2 rounds of the simulation to show that balanced systems, right? Delays transfer, gains never do. and there's huge dependencies. So we need protective capacity because there's still problems. So how do we get stability when we have all these problems? We use our protective capacity to do that. So what is a constraint? Anything that limits us from higher performance. Can be internal or external. Can be a resource, a process, a supplier, or the market. What is a bottleneck? So a bottleneck is where a resource has unexpected or excessive variation that cause a temporary buildup of work. But once we unblock that, right, then the pile of work in front of them dissipates. So it can be a machine breakdown, a quality issue, somebody calling off sick, a tooling issue, or a supplier issue. So go back to our simulation. So if we have only one weakest link, where is it? So where's the weakest link in our system here? So how do we find it? So one, we can look at the person with the most inventory in front of them, which would be Danielle, right? So maybe she's the weakest link. Or we look at the person with the least deficiency, which is Tina. So maybe she's the weakest link. We know it's not in the market, right? Because we didn't meet the demands. We got more demand than we have capacity. So we don't have a market constraint. So some companies have more capacity than they have demand, right? That's a market constraint. So don't forget about the market, right? We can have more capacity than we have demand, than we have an external constraint, not an internal constraint. So where's the constraint? Looking for answers. And you see how difficult it is just in this little simulation, how to identify where the constraint is.
Well, at current, the constraint's Danielle, because she's the slowest part of the process. But that may change if you speed her up. There may become another constraint that shows up later down the line.
Danielle, what was your total output?
140, I think. Just a second here.
That was your expected value. What'd you actually move?
78.
78. Okay. Anybody do less than 78?
66 for Joe 2.
Yep. Danielle's not the constraint. See how difficult it is to see?
Yeah, but Joe too can't process it if Danielle can't get it to her or get it to him.
Yep. But
So is he the
she did
constraint?
78, so she got it to him. He couldn't produce it. But why is his efficiency high? So nobody would pick Joe, right? So where's the constraint? Joe's the constraint. Because he has the least capacity in the system. He only produced 66, but when we look at efficiency, what's efficiency based on? What he produced relative to his capacity. People are scratching their head like, what? How's that possible? So in an unbalanced system that's not stable, it's very difficult to see where the constraint is. It's almost impossible. So every project that I've done in implementation, I ask companies where their constraint is. How many companies were correct? 0. Given the current data that they're looking at and how they analyze their system, it's almost impossible to see where it is. So when I go into companies, I ask them, where's your constraint? And they tell me, I said, that's where I know it isn't because nobody's ever been correct. And why is that? not having the right metrics. 2, it's an unstable system, right? 3, we have no visibility of the important information we need to look at to determine. And they have all this data they can show me, but no data I can see. So that's one of my sayings. It's like we take data, a sea of data, and turn it into data we can see. So I have all this data, but none of it's relevant for decision making.
I don't know if it's helpful, but I only rolled 5 more than I processed. So I rolled 71 over 20 days and processed 66. So only 5 additional.
And so what's interesting, I was going to say, if Joe didn't tell me what he produced, so I know he's a constraint, I would have guessed 66. Why would I guess 66? That's what we shipped. He determines the output of the whole system. It's exactly what he rolled, right? 66, right, Joe?
Process
That's what
66.
you processed through your system, 66. That's what we produced. He's the constraint. But none of the indicators would show us that. So just a quick story. I went into one company, right? They were 8-week lead time. They were 40% on time. I do the analysis, right? And they're like, where's your constraint? Oh, it's in our layout department. So their layout department is they do these huge forgings. They take the forgings. The first thing they got to do is find the center line on this forging so that they can start machining it. So when I go, okay, why is layout the constraint? They go, let's take a walk back. So we walk back. All these piles of these forgings piled up. See all the inventory? So my first question is, so what's the utilization? They're like, what do you mean? I said, how many shifts, how many hours are people working, and how much time are they actually doing layout work? Oh, we're running 24/7. There was 8 layout people, right? And I go, if I just did a random sample right now, I see 2 people out of the 8 doing layout work. So I guess your utilization is about, wait, 2 out of 8, 25%. And so they're like, well, so why aren't people working on stuff? So you don't understand. So I get that a lot. You don't understand. So no, I don't. Explain it to me. Oh, because what happens is with the layout, we have to take a core sample because it's aerospace products. We take a core sample of the material, we send it to a lab. The lab analyzes it for us, brings it back, and then when we get the results back, we say, okay, it passed the results, so we're going to release it to production. So maybe the lab is the constraint. So I just got one question. Anybody guess what my question is? How many of the samples failed the test? They said less than 1%. Then why are you holding them? Release them. Everyone has a serial number. If it fails a test, we'll go downstream and pull it out of production. But we don't release jobs until we have the test back as their policy. Stop doing that. Release the jobs. All of a sudden, the floodgates opened. Layout's not the constraint. Either is the lab. It goes to heat treat. Piles up in front of the heat treat. Okay, let's take a walk to heat treat. Go out to heat treat. My first question, what's the utilization? Right. So you see, that's always my first question. What's the utilization? How many hours? How many hours are they producing? They're like, we don't know. Okay, so do you ever have a situation where you have an oven available? So they had 8 ovens, but you don't have work to put in it. You go, oh, that happens all the time because we got to run a full load, right? We wait for a full load to pile up so that we can run the batch. Said, okay, how about this? Whenever you have an oven available, whatever you have to put in, put in. So if it's 1 piece, 2 pieces, 8 pieces, I don't care. Oven's available, put the parts that you have in the oven. They're like, we've been beat on for 25 years, never run less than a full load, right? Got to be efficient with our ovens. So I said, only 3 things can happen. We get better, we get worse, or we stay the same. So we changed that policy, said, whatever you have an oven available, whatever's there, put it in. the floodgates opened again. It doubled the capacity in that department. It was like mind blowing to me. So then think about counterintuitive. So we said, oh, so we also have a nitriding operation where it's got to put in a batch oven, right? And then it's got to bake for 3 days in this nitride environment. Let's do the same thing there, right? Whatever you got available, put in. They said, oh, there's a problem with that because the ovens are designed, they got to be symmetrical. So we have all these fixtures that keep them symmetrical within the oven. So we can't do less than whatever the batch size is for that fixture. I'm like, oh, okay. So one guy says, well, we have scrap pieces. Let's put scrap pieces as dummies in. So how counterintuitive is that? It increased the capacity 50%, putting scrap pieces into the, right? It's like, so it's like, it's so counterintuitive, right? And most people are in the efficiency mindset. No, we need to be in the flow mindset. So when we switch from efficiency to flow, it's amazing what decisions change. So I have example after example after example of getting 200, 300, 400% improvement in a process by just switching from efficiency mindset to flow mindset. I don't know if Diane, you want to talk about some of the things that you guys did and what effect it was?
Yeah, sorry, I was trying to unmute myself there. Yeah, we actually cut down the amount that was going through our saw because we realized we were pushing through too much through our saw, and then we had a ton of whip, and it wasn't helping our throughput at all. So we cut our saw operator down to about, I think it's 4 hours a day is what we had done. So we had less whip, and we wound up increasing our throughput on that side.
You see how counterintuitive it is? Like,
Yeah.
stop the guy from working half the day. What?
In order to speed up, slow down.
So first step is to find the weakest link, right? Our traditional measures aren't going to show us that. So how do we find the weakest link without going through all this analysis and getting an analysis paralysis, and then we're going to be wrong anyhow? Okay. So we have a multi-step process. So how do we synchronize the flow? So how do we control inventory and remain productive? So step one is choke the release. So that's what Diane was talking about. Stop releasing work into the system, right? If it's clogged up with inventory, stop releasing work. Then if you do that, you'll identify the CCR within 3 lead time cycles. And typically it'll be stable within 3 lead. So whatever your production lead time is, if your production lead time is 6 weeks, in 18 weeks, you'll be stable. So I did some work at a mattress company. Their lead time in production was 3 days. I'm like, this is going to be great. In 9 days, they're going to be stable. They're like, what? In 9 days, we were stable. And we increased. So I did analysis on the utilization. So I'm always looking at utilization. Where's the constraint? I had a sense of where it was. If you don't know where it is, pick one, right? That's the easiest thing to do. Let's pick one resource that we think's a constraint, and then the reality will tell us if we're right or wrong. So I picked their assembly area where they assemble the mattresses as the constraint. So I'm going to synchronize everything to that point. So I look at their utilization. They're not very good because they're constantly looking for stuff. They're missing stuff. They're moving stuff, right? They're not doing value-added stuff. They're doing a bunch of wasted activities. And so I met with the CEO. So the CEO says, like, what do you think the impacts would be? I said, I think we can get 40% more through the system. You got like 40%. It's like, how many resources do we need to add? I said, no, with the resources you have. He's like, okay. So we focused on that one resource, which is the assembly. We got everything synchronized to what their rate was. We have a technique we call full kit. So they have everything they need to execute their job. So the guys that Samantha and Diane understand what full kit is. So we have everything to execute that job before we release it. If we don't have everything to execute the job, we don't release it. Okay. So when we got full kit for the assembly guys, they could work without stopping. And then we had listen to their problems. They're like, well, the toppers come out not in the sequence we're building, so we got to sort through all these toppers to find the one that we need. So okay, people upstream, you're going to sort the toppers in the sequence that they're going to build it, right? So you guys at building the mattress, tell them what sequence, and they'll sort the toppers. And so what was the impact? They were doing 30 mattresses a day. We just synchronized to the assembly. We went to 50 with no overtime. So they were 30 a day with massive overtime. We went to 50 with no overtime. So I had to go back to the CEO and said, "Oh, I was wrong. It was 60% improvement." He's like, "That was in January. March was the record shipment ever in the company's history. 2 months." So that's the type of impact we're talking about if we get the right focus. So we need to identify the CCR. So if we don't know, we pick a resource, we start releasing material based on that resource's capacity, right? And then once we understand where that CCR, we want to establish the correct inventory profile to protect the system. So our most important resources in our flow is our customer and our constraint. We want to have the most inventory in front of those two resources. So shipping, we want most jobs at shipping ready to go, or just got to be packaged and shipped. And then we want most inventory in front of our capacity constraint resource. Then we need to make sure that that capacity constraint meets the demand every 2 days. So before I was just checking after 10 days and like, where are we? Oh, we're behind. Let's pick it up. No. So now we're going to cut the management window to every 2 days. We're going to monitor how we're doing against our customer orders. Okay. Then step 5 is if we get more than 1 day behind, we need to increase our capacity at our constraint. But instead of running overtime, we're going to ask people to come help them. So before we add any cost, let's utilize the resources that we have. So in this round, we're going to allow people to share their dice with the constraint if we're behind to catch up. So how we do that I'll show that in the game here quickly. Let's talk about the inventory profile. So we want to have most in front of customer tapered back to our capacity constraint, most in front of the capacity constraint tapered back to the release. Then the choking mechanism, Joe, you're going to tell Roy every day what to release based on what you complete. So if you move 5, you're going to tell Roy release 5, even though Roy might roll 10, right? We're going to only let him work half a day, just like Diane was saying. Questions on that? So let's look at it. Let's look at the sharing first of all. So let me bring up so on your operator tab, let me go to round 4. You have this 2 tabs here for sharing. Oh, it doesn't say sharing there, but it should say sharing. Oops. Second. There we go. So if Joe needs help or anyone else needs help to get the work in front of them flushed out before we run overtime, we're going to ask people to share. So if you want to share, you're going to say yes, and then you're going to pick who you're going to share the dice with. Okay. And what it'll do is it'll share one of those dice with the other person. Questions on that? And then we're going to look at the system every day and determine like how we doing against performance. Is Joe on schedule? What's our profile look like? We only share dice when our profile gets out of whack or Joe gets behind more than one day. And then we'll say who should share dice. It's the person with the least amount of work in front of them, right? That can share dice. So let's set the inventory profile. So we're staying with the same amount of inventory every round. So 36 is our total inventory. So Joe is our capacity constraint resource. So how much inventory should we put in front of him? So I have 3 rules for setting the inventory profile in front of the capacity constraint. First rule is be paranoid. Second rule is be paranoid. Third rule is don't be hysterical. Okay, so we know 1 day in front of Joe is too little, but 10 days would be hysterical, right? We don't need 10 days of whip in front of Joe. So what would you feel comfortable and how many days of work in front of Joe so we never starve him, but we don't have excess inventory? Usually we go 2.5 to 3 days.
I was gonna say, how about 3?
Okay, 3. So we'll put so it's 7, 8, 9. We'll put 10 units here. Okay, so I'm going to put 10 in front of Joe. Then I'm going to go to shipping, right? So that's our next. So how much do we want to have in shipping? So I have a lot more capacity than Joe, so I don't need to be as paranoid. So I don't need 10, right? I could go 5 or 6. Let's do 6. And then I'm going to taper it back. So in front of Tina, I don't need as much. So let's go 3. So you see 6, 3, then 10, and then we taper back from here. So we got to get a total of 36. Let's do 6, 4, 3, 3, 2, 1. Oh, that's 38. So I got to take a little bit out. 2. 5. 3. So now you see I have 36 totals. This whip's the same, but I'm redistributing. So if I go to my company view, now I got most in front of Joe. So he's our CCR. Tapered back to Roy. The most in front of me, tapered back to Joe. So we use inventory as a decoupling mechanism. So what does that mean? I don't want the variation from all upstream to affect Joe. So I put the inventory there as a shock absorber to keep the variation, all the delays up front here from affecting him. So just decoupling your operation, you'll get results in days. So what we did at Diane's company is we thought the saw was the constraint, right? So we said, okay, here's the release schedule for the saw. Work piled up in front of their milling station or their CNC machine. So oh, CNC machine is a problem. So now let's, based on CNC capacity, let's release jobs based on their capacity. So now we have the work in front of the CNC machine. All other machines in front of that, if there's a delay, it doesn't stop that machine from working. We never want to starve that resource. So that's what we're doing here, right? Keep this work in front of Joe, never starve him, and decouple everybody upstream from affecting Joe's capacity. So just decoupling will increase productivity 25% of the system. Okay. So then we're going to monitor every 2 days how Joe's performing against demand, against our orders. And then Joe, every day you're going to tell Roy what you rolled, and that's what Roy's going to release. So sometimes we'll have a situation where Joe rolls a 6, but Roy rolls snake eyes, right? So Roy can only release 2, because that's what his operation did. How do we catch back up? The next day we let Roy sprint. So our protective capacity is what we call sprint capacity. So we let Roy sprint to catch up. So think about us all walking in a line, right? So we're all walking in a line at Joe's pace. All of a sudden, right, there's a problem. Dave has a problem. Stop and tie his shoe. What happens? A gap forms between Joe and Danielle. Well, we need these people to sprint to catch up to Danielle, but don't run past her, right? Doesn't make good to run past her. Run and catch up. So that's what we call sprint capacity. So we sprint and catch up. Any questions? So this round, rules are the same, except Joe, you're going to tell Roy what to release every day. That's what he's going to release. We're going to monitor the profile. So I'm only checking 3 things in this round. Joe, you're on schedule. Profile's good. Roy, you're on schedule. If those things are good, we move to the next day. And when I say Roy on schedule, he's released everything that Joe told him to release. Okay, any questions? Okay, let's start with round 4. Okay, so I'm rolling day 1 for everybody for round 4. Okay, day 1's complete.
And I got a 1.
Roy's going to release 1. Not a good start. Okay, day 2, rolling day 2.
Three.
Okay, so we should be at 7. You're at 4, Joe, right?
Yep.
We're not more than 1 day behind, so I'm going to let it roll 1 more day. So Roy's been able to release everything, right? So we got profile looks good. Joe's a little bit behind, but let's see what happens the next day, and then we'll decide if we need to take action. Okay, day 3, I'm rolling day 3.
Two.
Okay, so now you're more than 1 day behind, right?
Do I have a loaded die like towards the low end?
No, it must be operator error.
Ha,
So now we need somebody to help. So there's multiple people that can help here, right? So Danielle, probably our best candidate. Can you see on your screen, Danielle, the share?
Yep.
So you're going to say yes and then pick Joe Cooper 2 to share with.
Okay.
Good.
Ah.
Okay, rolling day 4. So Joe, you should see 2 die now in that.
7.
And Roy, can you release 7? Yeah, so he rolled 11, right? So he's good shape, right? So where's that put us according to demand, Joe? So you see you have the running total and the target, so you should be right on target. Your running total should match your target.
Oh. Yeah, target average of the target.
Target's 14. I mean, what's your running total?
That share word.
Running total 13.
Yeah, so we're right almost back on schedule, right? Target, we should be at 14. He's at 13.
And we lost Danielle in there too.
Yeah, Danielle battery just took a crap.
Oh,
Sorry.
What operator number were you, Danielle?
she's right next to you, 5.
5.
She's 5.
Can you
Okay.
put both those in, Dave, or no? Just
Yeah, I will.
Okay.
So let's see, Dave.
So did she enter in
right? We're on day 4. Yeah.
Yeah, so
Okay. I'm good.
she did 4. So now I'm running 5, so I'm gonna put in day 5.
This is 5 now.
Yep.
I still have 2 dice.
Forgot to unshare.
Oh, sorry.
So you can stay with the 2 dice, Joe, if you want.
I turned it off.
So for day 5, you can do the 2 dice again.
Okay.
Forgot to send the resource back. So what was your?
Oh, 7.
Can you release 7, Roy? Yep, he can do 7 again. So one of the
Recording in progress.
So one of the keys here is like we can't starve the release, right? If we do, Joe gets too many days in a row where he doesn't meet demand, we're going to starve the system of inventory, right? We got to make sure we don't starve the system. Okay, so you did unshare, Dave, right?
Yes.
Okay.
Still seeing 2, but
I haven't rolled yet, so now I'm rolling day 6. So day 6 is complete. You should have 1 die now, Joe.
Yeah, with a big 1 on it.
Where's it put us relative to demand?
Know how to what?
Target 21, running total 21, by the way.
Okay, right on schedule. So that 1 didn't hurt us. Okay, so how's our inventory profile look like? So we're protected in shipping. Joe's a little bit light, so we're a little bit concerned that we're going to starve him here coming up. We just got to get this material moved through Dave and Danielle and get it in front of Joe before we starve him. If we have a problem, we'll run overtime to get this inventory moved through. But right now, I'm not going to take any action. I'm going to see what happens. Okay, so day 7 rolling.
5.
So we're a little bit ahead of schedule, right?
Running total 26, target 24.5.
Okay. So we're starved for work. I see it coming. We're still not totally in trouble, right? We'll see if Danielle's be able to move this stuff through. If not, we'll take action. Okay. I'm not going to waste any overtime right now to move that through. So day 8, I'm rolling day 8 for everyone.
I see this.
Uh-oh.
What'd you get, Joe?
I should have taken rest.
6 for day 8, right?
Yes.
But you only moved 2, right?
I only had 2 available, right?
Okay. So we're still good on demand rate, right? So we put a little bit more inventory in the system so we can choke it off here in a little bit. So I'm doing day 9 right now. So day 9, everybody roll. It's done. So I'm actually a day ahead in shipping, right? So we're just finished day 9. We're at 35. Okay, Joe's a little bit light, but I see the stuff coming, so I'm not going to take action. So where are we at against demand, Joe?
Total 31, target 31.5.
Okay. So we'll catch up here with that work in front of Diane getting to him in a couple days. And what you'll see is the inventory profile will correct itself. Okay, so now we're doing day 10. So our day 10 is complete.
3 again.
I think Roy's a couple days behind.
Hmm.
There we go. Okay, now we're caught up. Okay. Profile's correcting itself, so we're in decent shape. Day 11, rolling for 11. 11's complete.
1,
Where are we at relative demand?
total 34, target 38.5.
Okay. So I'm gonna let it roll one more day, and then we're gonna probably have to have somebody help Joe. But I want to get the profile corrected first before I run overtime. Okay, so now I'm gonna do day 12. So our day 12 is complete.
3,
Okay, now we're gonna ask somebody to help. So we're more than one day behind, right, Joe?
5, total light.
Okay.
Or
So now we need somebody to share with him. So actually, I can do that. I'm probably the best candidate to share because I only got one here. So I'm going to share with Joe. So I'm just sending a resource over to help him. And so a lot of times we get like, well, that guy isn't trained to do that step, but we think about the surgeon concept, right? So we want to keep the people that are skilled in their task doing their task and taking stuff off of them that they shouldn't be doing, like material handling, right? Going to get materials, going to get their next job information, right? Let's have those helpers do that so we can get the utilization up on our capacity constraint. So I shared with Joe that one, so I'm doing day 13 now. Hopefully I gave you my best guy.
I'm only seeing one. Oh, you gave it. Oh, no, that's correct. Yeah, I'm only seeing one die. I should see 2, right?
Yeah. That's strange. Oops. Second. Gonna roll one more time quick to make sure that you still only see one.
Yeah, and it's still the same number. My other one changed. Did you choose the right? You choose Joe Cooper too?
Yeah.
Okay.
Yep.
I guess we could just add 3.5 or something.
Let me try one more time. About
Yep,
now?
that did it.
Okay.
7.
So
Well,
what do
I
we want
rolled a
Roy to
6.
release? So we want Roy to release up to the target. So far he's released 49 targets. So just do the 4, Roy. So now he's right almost on target. So because we had a little bit extra whip in the system, I just choked it off a little bit more. Okay, so now we're back in good shape. So profile looks good.
You want to stop sharing too, or did you
Yep.
already? Okay.
Okay, day 14. Okay, 14 should be done.
3.
How are we doing against schedule?
47 versus 49. Target of 49.
Behind. Okay, let's go another day, see how it goes. So day 15.
Again. 50 versus 52 and a half.
So can somebody else help him out? Diane, maybe? Can you share Diane with Joe?
Yeah, I can
too?
do that. Okay, I think I did it.
So you said resource sharing, yes, and then took Joe.
Yep, Joe
Okay.
Cooper too.
Okay, so I'm rolling for day 16. Did you get 2 dice there, Joe?
Yep. 5 is the total. 55 versus 56 now.
Okay, so we're back.
And you want me to stop sharing?
Yeah. Someone delete a number out of there. If you hit delete, it screws up the formulas. You just gotta.
I think I did something. I'm not sure.
Yeah. Is everybody's numbers corrected now?
Oh.
Okay. Are we gonna have somebody else help Joe? Or are we in good shape? So Joe, where are we at?
51 versus 56.
50 what?
51 versus 56.
Should we have Aaron help him?
Yeah, I've only got one on my whip. I
55
can help
versus
them.
56.
I can share.
55 versus 56.
My screen. Oh, yeah, you're right. I was looking at my other screen. Sorry about that. It's trying to switch back and forth. 55 versus 56. You're right.
Wait, which day are we on?
So we should finish day 16. So 16 should have data. So Tina, you got to put in 16.
Okay, there we go.
There we go. So let's look at our point of no return. So we're day 20, 19, 18, 17. So what's in front of Aaron right now is the end of the month. So right now we have 56 plus 3 is 59 plus 5 is 64 plus 9. Yeah, we got enough in the flow to meet the demand as long as Joe executes, right? So we don't need to move any more inventory. We're in good shape with inventory. We just got to make sure Joe flushes this out. So do we want to have someone share with Joe just to make sure we get that pile in front of him moved?
I was gonna say I can share.
Who was that?
Do you want me to share?
Tina?
Yeah,
No,
not yet.
we need to stay. So
I
Aaron would
can
be
I
the
can
best.
share or
Aaron
okay.
would be the best one to share.
Yep.
Aaron, do you want to share?
Yeah, I have it now.
Okay. So we're on day 17, so I'm rolling 17.
6 total.
Okay, we're in good shape. So we should be ahead of schedule, right, Joe?
61 versus 59 and a half.
Right now we got 59 plus 4 is 63 plus. So the end of the month is right in front of Tina. So we're perfect shape. Okay, you can stop sharing, Aaron.
Got it.
Now the pressure's on Tina. Okay, day 18.
4.
We're in good shape.
Yeah. Got to do my other one. Thanks.
Okay, day 19.
4 again.
Okay, are all set as long as even if I roll snake eyes, we're good. Okay, last day, day 20. Day 20 is done.
So I don't need to read out anymore, do I? 2 was the number.
2.
Yep.
What was the number for day 19?
2.
Day 19 was 4.
Oh, 19. Okay. Okay. Let's look at our results. Okay, so we met our demand of 70 units. So our throughput went to 21,000 because we shipped all 70. No overtime, so we just leveraged our resources to share. So operating expenses say 18,000. So our net profit went to 3,000. Our inventory dropped from 19,800 to 8,200. 100% on time. Lead time went to 11.7 days. Highest productivity, and then $2,000 in positive cash. So what happened that round? So let's look at the efficiencies. So how many people's efficiency went down? So not very good efficiencies, 52, 60, 50, 55, 45. Joe was good here, 101.
Setting the world on fire according to regular metrics.
Yes. So everybody's efficiency went down, but we got the best performance of any round. How's that possible? That's why I said you're gonna be shaking your head. It's like, how did that work? So if you look at the work in process in your system, right, it tells you a lot of information, right? So I did work with one company and they had 13 weeks of WIP. They said, well, where's our capacity constraint? Well, I know it isn't the first operation, right? I don't get 13 weeks of WIP in the system if the first operation is a constraint. So I can eliminate that one automatically. And in this company, we actually stopped releasing for like 3 weeks. So we went from 13 weeks to 10 weeks in 3 weeks. And people were freaking out. And so what I did is I moved those resources from the release point downstream to have them help downstream operations. And it was a union environment, so it wasn't easy. So we got a special classification for training agreement from the union to be able to move people so they keep their same rate, the training rate that they would normally get paid, even though they're working in a different department. And we took, in about 4 months, we took their lead time from 13 weeks to 9 days. Sort of similar performance we see here, right? Our lead time went from 30 days to 12 days. Right? So we're not focused on that value added time. We're focused on trying to reduce that queue time. So the key here is protect Joe, right? Decouple Joe from the rest of the process. Don't let delays from upstream affect his productivity. Any questions on that? So the paradigm shift for this is for the entire system to be more efficient, most processes need to be less efficient. That's a hard one for companies to understand. And people struggle with it all the time. We've been efficiency driven for years and years and years, and then people struggle with, right, that inefficiency. And Diane, do you want to share like the recent discussion we had with your team about the efficiency?
Yeah. It was what on one of the parts, as opposed to batching similar products together to get something out the door was one of the biggest discussions that we had. And I can't remember. I think it's been going better back there now. But I think that's what I remember from it.
Yeah, so when I work with companies, we only have one rule. So you want to share what the one rule is?
Okay, sorry. I can't, for some reason, I can't see the entire screen.
Oh.
Always follow the rules.
Yep. So that's our one rule. We follow the rules. Right? Don't break the rules. So what happens is people want to break the rule. So the rule is, right, keep the capacity constraint, our single point resource, highly utilized. Don't release more into the system than what that resource can consume. And then we have a priority system, follow the priority system. So Diane's company wanted to violate the priority system, right? They wanted to break the rules. But when we break the rules, right, we're trying to go back to old practices. So the rules are in place to reinforce the new practice that we want of focusing on flow and remaining synchronized. And I had a discussion with one of the operators, and he's like, so I got these two jobs that are the same setup, but they got another job between them. So why can't I go to this third job, right, and utilize the same setup? Why do I have to go to the second job, do a setup, then reset up the same job to go to the third job? Right? And it's like hard for people to understand it. It's like, well, because the second job is needed by the customer sooner than the third job. And I said, it'd be like you going to the supermarket and you're the third person in line, and the person in front of you has milk. The second person has bread. You have bread. The person behind you has milk. And then the fifth person has milk. So the checkout lady says, oh, I'm checking out milk now. So everybody with milk come to the front of the line. And you check out before, because I don't want to change over, right, to check out bread because I'm checking out milk now. And the people with the bread, you wait for all the milk people to go in front of you, right? That's the scenario. He's like, well, that doesn't make sense. I said, that's what you're doing. So he's like, oh, so we want to sacrifice efficiency for on-time delivery? I go, exactly right. So he got it just like that, right? We don't sacrifice on-time delivery for efficiencies. And that's hard for people. Right? It doesn't make sense to set up twice for the same job. From an efficiency perspective, no. But from a system perspective on delivery performance, yes. I have another story with a company where they had a job for 10 units, and each unit had 10 sub-assemblies. So what the lady was doing is she's setting up for the first sub-assembly, making all 10 sub-assemblies. Then she sets up for the second sub-assembly, makes all 10 second sub-assemblies, sets up for the third sub-assembly, makes all 10. I go, no, make one, move one. So make all 10 panels for the first assembly and move it. Set up, make all 10 panels for the second assembly, move it. And the president goes, that's not very efficient. She's going to do 10 times more setups. I go, yep, I agree. It's not efficient for her, but it's efficient for the system. That's the difference in system thinking. So make one, move one. Yes, she's going to be less efficient, but the rest of the process is going to be more efficient because I'm going to do parallel processing. So now I get one unit moved to testing while she's building the second unit. Then second unit's going to go to testing. First unit's going to go to packaging, right? I'm going to cut the lead time by like in half just doing that. And if there's a quality issue, I find it much sooner. Okay. So round 5, due to our increased operational performance, reduced lead time coupled with improvement on-time delivery, customer orders have increased. So now from 70 units a month, our demand's gone to 80 units per month. So the question is, what do we change to meet the new customer demand? Anybody have suggestions? So we apply what we call the 5 focusing steps. So the 5 focusing steps are identify the system constraint, decide how to strengthen that or exploit that constraint, subordinate everything else to that constraint, elevate the constraint, and then if the constraint's broken, go back to step 1. So if the demand, so where's the constraint right now? Is it internal or external based on our 70 demand? So Joe, what did you produce? I would assume you produced 72.
Going to my other 71.
Okay. So 71, our demand's 70. So where's the constraint? In the market, right? We need more demand. So now with our improved performance, customers say, oh, we'll give you more orders. So now demand goes to 80. So where's the constraint now? If it was 80, goes back to Joe as the constraint because he only has the capacity to do 71. Our demand's 80. So Joe's the constraint. So from my experience, what I've learned, every problem can be classified into one of 3 categories. It's a synchronization issue, it's a capacity issue, or it's a variability issue. So a synchronization issue is we have disruptions when we have multiple things that need to come together and one component's missing. Right? So I got 4 things I got to assemble. I only have 3 of the components. I can't assemble it because I don't have all 4 components. That's a synchronization issue. A capacity issue is I got high utilization on my resource and I still can't meet the demand. A variability issue is I have enough capacity, but I have too much downtime from setup time or machine breakdowns or right unavailable operator or so forth. So in this simulation, do we have a synchronization issue, a variability, or a capacity issue? So let's look at Joe's data. So round 4, 1, 3, 2, 7, 7, 1, 5, 6, 3, 3, 1, 3, 7. So what do we see in this data? Lots of variability. So we have a variability issue. Even though it appears like a capacity issue because he showed the availability with single dice a roll of 6. But he also has these days where he rolled 1s, right? So what I want to do is I want to eliminate the 1s and 2s. Right? If I just reduce the variability and said, okay, Joe, you can only roll 3, 4, 5, or 6. That's reducing his daily variability, right? Capacity increases as a result of doing that. So I had lots of discussions with people about this subject. They're like, no, it's a capacity issue. No, it's a variability issue. So we don't look at variability from a capacity perspective like we look at variability from a machine, right? So I don't know if I can show I can do a whiteboard or not. See my whiteboard option. Anybody know how to do a whiteboard in Zoom quick?
Yeah, it's down in your menu there, Max. Right between the apps and the notes.
I don't see apps. I don't have the right view here. Let me stop share quick.
Yeah.
Ah, there it is. I can reshare. Can everybody see that? The whiteboard or no? You can see the whiteboard?
Yep.
Okay, so when it comes to capacity, I have my dice, right? I can roll a 1 or a 6. Right? And what I normally would see with a dice roll distribution is this normal distribution. Right? With my average at 3.5. So when we look at variability from a process perspective, we say, oh, we want to shrink those limits in, right? We want a distribution that looks like this, right? That would be reduced variability from a process perspective, like if you think about quality. Right? But when we think about capacity, it's different. So we have our distribution like this. What we want to do is we don't want to eliminate the 6s and 5s, right? We want to cut this off. We want to eliminate this part. So our new distribution is going to look like this. So now, instead of having an average of 3.5, what do we need the average to be to meet 80 demand?
4.
4. All I got to do is a half a unit of capacity a day to meet the new demand. So if I just prevent him from running 1s and 2s, meaning I might have to do setup reduction. If setup is a problem, I might have to do machine maintenance if downtime's an issue. I might have to do a quality initiative if I have scrap issues. So whatever the things cause us to do the 1s and 2s, we want to eliminate this. So this is where we do our targeted lean event and say, okay, I need to do a total productive maintenance because we have too much downtime. I need to do a setup reduction because I got too much setup time. I got to do, right, cross training because sometimes people don't show up and we don't have the right people to run this process. So depending on what the delays are, so what we want to do is when we start this process of synchronizing, capture for Joe on his operation when he has less than 4 why did he have less than 4? And those reason codes why he wasn't able to produce an average of 4 per day. That data will tell us what are the highest instances of downtime that caused us to not meet the demand for that day. So we can do 2 things in round 5. We can do nothing and have people share dice to help Joe, or we could do a targeted improvement event at Joe's operation to reduce his variability in his process. Anybody have a suggestion what you want to try this round? So what I can do is I can go to Joe's operation here, see his average is 3.5. I can just say, okay, the minimum he can roll is a 3, and the maximum he can roll is a 6. That automatically takes the expected value to 3.5 or 4.5. Enough capacity. Now I got to be careful that I have enough protective capacity in these other resources, right? If I get too many resources that are close to 4.5, I'm going back to a balanced system, which is dangerous. So if I increase his capacity, let's see if I put 2 in here, what happens? So 2 will get us right there, right? So I just eliminate him from rolling a 1. So he can only roll a 2 to a 6. The average expected value is 4. Then I got to be careful that anybody else that gets close to that, I start to go balanced. If I get too close, so let's say, right, we go to 4 here and it says, okay, our average goes to 5. Now this resource here, Samantha, and Dave are at 6. That's not enough protective capacity. Our general rule is 20% protective capacity in non-constraint areas. Then I'd have to go do some improvement events to these 2 resources to increase their output. Any questions on that? So let's say we do a quick improvement event at Joe's operation. We reduce the variability, reduces downtime. It gets us to 4, right? That's enough to meet the demand. We have enough protective capacity elsewhere to support that, so we don't need to make any other adjustments. The next question is, what do we make the inventory profile? Do we need to adjust the inventory profile? So this is another hard concept. Don't put more inventory in the system when you increase capacity. So let's think about it logically. If we had 0 variability, that everyone rolls a 4 every time, how much inventory do we need in the system? So if everybody had 0 variability, everyone could just roll a 4. How much whip do I need in front of Joe? 4. As you reduce variability in the system, you need less inventory in the system. Again, it's counterintuitive. The more variability, the more inventory. The less variability, the less inventory. So if I reduce Joe's variability, is the only one I care about. If I reduce his variability, I can get away with less inventory. Again, it's so counterintuitive because that's not the way we were taught, right? It's like, well, if I increase capacity, I need more jobs on the floor. No, you need less jobs on the floor. What? I did that in one company where they had a lead time of 8 weeks. I think I told you they had 40% on time. So I do my analysis. I said, well, the problem is you got too much lead time. You need to go to 6-week lead time. They're like, you don't understand. We're 40% at 8 weeks. We need more time. I said, no, you need less time. They're like, what? We cut the lead time to 6 weeks. They went to 90% on time. You see how system thinking is totally different. It's counterintuitive because most people aren't trained to think system wise. Okay, so this round we switched. We did the improvement on Joe. We increased his capacity. We kept the profile the same. Now our demand's 80. So now it's same rules as before. We're just going to run like we did last round. We're in round 5. Same rules apply. Questions for this round? Okay. Let's run, see what happens. So we're in round 5, day 1. So enroll. So day 1's complete. So enter in day 1. Of course, Joel rolls a 3, right? So turn on your speaker.
I said right. Yeah, I just muted myself.
So Roy should release 3.
Yep, 3.
Okay, day 2, rolling.
It didn't change.
3
It's a
again.
3. It's a 3.
Okay, day 3.
5.
Okay, profile looks good. Joe, you're probably right on schedule, right? Or low, 1 behind.
1 behind.
Roy, you're on schedule, looks like. So moving to day 4. So day 4 is complete.
6.
There we go.
1 ahead.
Good. Okay. Day 5.
6.
So we might want to choke it off here in a little bit. So we're actually more inventory than we need in the system. So we're ahead of schedule, right, Joe? So you're ahead of schedule. You only got 3 in front of us. So I'm not going to freak out, right? The profile's light, but he's ahead of schedule. Okay,
3 ahead.
day 6. I'm rolling day 6. 6 is complete.
5. Two ahead.
Okay, Roy, you're on schedule. Yep. Okay, day 7.
3. 1 behind.
Okay. A little bit light on the profile, but stuff's coming. So we're going to be 1 behind for a few days here. Okay, day 8.
6. 2 behind.
Okay, day 9.
Pulling out the actual roll, right?
Yeah, so we want to stay on schedule at the release. So
Says the order's processed. 2.
where does that put us relative to demand? See,
Uh, 4 behind.
Yeah, so Roy's actually ahead of schedule by 3. So we got a little bit more whip in the system, so we're okay. So again, we don't want to start the system of work in process. Okay, day 10.
Five.
So we're only one off of shipping on time. Okay, and the profile will start correcting itself here shortly. Okay, day 11.
2. 6 behind.
So Roy's good. So we need somebody to help Joe. Who can help, offer up help? Looks like Tina.
Okey doke.
Okay, so Tina's going to send a resource over to help Joe. So we're on day 12.
Okay, done.
Did you see 2 dice, Joe? Yep.
Yeah.
That was a big roll.
10.
So we need Roy just to release up to the target. So we got way too much whip in, so you want to cut it back. You just want to do 6, Roy. Yeah, so that's still a little bit above target. So remember, relationship, we have too much whip, lead time goes up. Cash goes down. Okay, so we should be back correct. Are we back corrected, Joe?
2 behind.
Okay. So you want to send the resource back? You want to stop sharing, Tina?
Yes, I did.
Okay. Okay, so let's do day 13.
Five. 1 behind.
Okay, catching up. Good. Day 14. Done.
Four. 1 behind.
Somebody want to help me out? Yeah.
Me, I got my own problems.
I
You
can.
want me to do it again, Max?
For some reason my one day didn't take here. Yeah, somebody could help me out. Probably not Tina. Dave,
Probably me.
Dave Chrysler, can you help me out?
Yep.
So what I'll do is I'll have 3 dice now.
Okay.
Okay, day 15. That was a big one. Thanks, Dave.
Two.
Okay, you can
3
start.
behind.
What's that?
3 behind.
Let's see what we got in the pipeline here. So we got 20 more that we need. 16, 20, 19, 18, 17, 16. So back to what's in front of Diane, we need 20 units. So we got what? 8, 10, 14, 18. Yep, so we're in good shape. Okay, day 16.
Four. 3 behind.
Do I have somebody help him out? Maybe Diane?
Yeah, I can do that. Who is it? Oh, Joe.
Go to.
I'm always the problem. Sorry.
Ready?
Yeah.
Okay. Day 17.
Six.
Doer.
One behind.
Okay, so Roy's one ahead, so we're in good shape at the release. Okay, so 20, 19, 18. So what's in front of Joe is the end of the month. We got 60, we got 70, 76. So he just needs to get 4. So how confident are we that he's going to get 4 with one roll? Or do we want to have somebody help him out just for sure?
Do we add some help?
Yeah, I can help him.
So Dave's not confident. So
I've
Aaron, you
seen it
need help?
before.
Aaron, you said you'd help?
Yep, I got it.
Okay. Okay, so day 18. So Roy, I want to choke you off a little bit for this last couple of days. So just release up to target. So release 3 or the release point. Yeah, we're right on target now. You should
I
be in
had a
good
5
shape.
and Aaron added a 6, so it's an 11.
So we're in good shape, right?
You're asking me, aren't you? I'm one ahead. 73 versus
Roy's
72.
right on schedule. The profile looks a little bit light, but we're not too bad of shape. We got stuff in the end of the process where we need it. So, okay, day 19. Of course, I have a bad roll. So I need help. Who wants to help me? Tina, can you send one over to me?
Yes, I will.
Okay, last day, day 20. It didn't come across.
Did you see it, Max? I'm only seeing one.
Yeah, it didn't.
One.
Let me roll
Okay.
again.
Should we use the second roll?
I had to roll because the 3 dice didn't show up for some reason. It's not still
Okay.
still not showing up.
Hmm.
But I rolled a 7 anyhow, so did anybody else share with me before? I know Dave, you did, right?
Mine is off.
Oh, I do have 3 dice there.
I see 3 on yours, Max.
Yep, I was on the wrong tab. But she helped out because that's what we need to get to the finish line. Okay, so Roy was right on schedule. So I want to see this target against running total right. What we see there equal. Can you see my screen or no?
Yeah.
Okay.
Yeah.
Let's do our performance for this round. Okay. Throughput up to 24,000. So we met the new demand of 80 units. Operating expense, we didn't run any overtime. We did a lot more sharing this round. So you notice there was a lot more sharing, not only with Joe, with other resources. Because again, as we get closer to that balanced capacity, right, we might have to share more. So our net profit doubled to 6,000. Our inventory went down, right, because our average output went up. So the amount of inventory in the system, we need less inventory. Our lead time went to 8.5 days. So it's like, wait a minute, our demand went up and our lead time went down. What? Again, right? If we got the same inventory profile, we're getting more out with the same inventory, the lead time comes down. Productivity 1.33, so now our cash is up to 6,400 plus. Questions on that round? Okay, so what are contributors to poor flow? Our cost mentality, cost reduction mentality, so trying to save costs at the expense of throughput. So reducing workforce to save costs, making isolated cost reduction decisions, batching work, so driving high efficiency and utilization everywhere, batching decision making, so waiting for meetings to make decisions, wrong performance metrics, bad multitasking, switching from one task to another before finishing a task, or problem solving skills, so adding more non-value added steps in the process, or misclassifying the problem. So remember I said people would look at this simulation, say it's a capacity issue when it's a variability issue. So the tools to address capacity issues are different than the tools to address variability issues, which are different than the tools to address synchronization issues. So properly define the problem and then apply the right tool to fix the problem. Okay, achieving flow, focus on flowing from the start to finish in the most effective manner. Transition from batch and queue to synchronous flow results in quicker response to the customer, shorter lead time, reduce work in process, improve quality, improve cash, reduce costs. So how do we go about changing the culture? First, by educating people on synchronous flow, and then scheduling a plant using synchronous flow techniques. And the technique we use is called simplified drum buffer rope. It's the best technique for job shop environments. I have additional techniques that I've utilized to help actually improve the flow more in the job shop environment. So key understandings, activating a resource and utilizing a resource are not synonymous. Our goal isn't to utilize the resource. The goal is to activate resources when we need them to work. And then when they don't need to work, stop working. So just like the symphony, there's a time to play and there's a time to wait. We want to stay synchronized. You have to wait, right? And then when you're asked to work, work. And then when there's no work, wait. Okay, so activating means finding work for the resource by pulling orders ahead or producing a forecast. Utilizing means working a resource to make money out of the resource's work. So synchronous flow, each job has a predetermined time based on its complexity and quantity. So we call it reliable production lead time. Jobs are only given a release authorization and a lead time before the job is due in shipping, which is the choking mechanism. Jobs currently released are released too early are frozen until they're within the reliable lead time. The gating operation at a release point is held accountable to meet the daily release schedule. Inventory is strategically sized and located to protect the flow. So we want to decouple that capacity constraint from the rest of the system. Bottlenecks are identified in corrective action daily to unblock the flow. And then we use what we call buffer management as our priority system for the shop. Okay, so synchronous flow approach, inventory is controlled and strategically positioned. Lead time becomes short and predictable. Cash is no longer a scarce resource. Quality problems are found earlier. Results of a decision making is known immediately. Due date performance is improved. Profitability increases. Customer satisfaction improves. So our key learning, pros and cons of various operation environment and management methods. Describe the methods of synchronized operation with the demand to create a stable system. Explain the relationship between optimizing system performance and individual process performance. Okay, so that's our session. So if I go back to our data from our simulation, right? If we're going to give a promise date to our customers, how many days are we going to promise? 9. What's the chance we're going to hit it? 100%. So remember, the work in process dictates the lead time. So that formula that I showed, let me go back to that formula. Lead time equals inventory divided by the daily rate. Okay, so if I want to reduce lead time, how do I do it? Right, so I got a numerator and a denominator, right? So if I want lead time to go down, what do I need to do? I either need to reduce the inventory, right? Make the numerator smaller, or increase the denominator. Correct? But there's a inflection point that we found that, so the logic is for each unit of inventory reduction, it needs to have a bigger impact on lead time reduction. If I start reducing inventory and the lead time doesn't respond to either more or equal to, you'll start to flip and go the opposite direction where lead time will start to go up. I reduce inventory too little, lead time will go up. So why does that happen? Because then we create the huge dependencies in the system and all delays transfer right downstream to the customer. So there's an important right amount of inventory. Going too small negatively affects lead time. So in lean, it's like reduce inventory, reduce inventory, reduce inventory. No, there's a minimum amount of inventory you want to have in the system. If you go below that, you'll negatively affect lead time. So right sizing the inventory is important. The amount of inventory is a function of how many steps you have in your process and how much variability you have in your process. There's no single answer for each company. It's a learning exercise. So Diane's company went through that learning exercise and try to right size that inventory. And what they do is they have a lead time for each job. Jobs have different lead times. So jobs get released at different points depending on their complexity. The more complex, the longer the lead time. The less complex, the shorter the lead time. So sometimes a shorter lead time job will get released after a longer lead time job, even though the shorter lead time job has an earlier due date. So it's not managing to the due dates, it's managing to the release dates. So what did we do in this? In rounds 1, 2, and 3, we were pushing jobs into production. Round 4 and 5, we went to pull, right? Pulling jobs through based on resource availability. So just switching from push to pull, this is a type of impact that we see. Questions? I'll open up for questions now. Comments? I have a beautiful solution for a job shop to control the WIP. So in a job shop, the WIP isn't number of jobs, it isn't number of pieces, it's hours of work. So if you're a job shop, every job going out has different work content. You can't do number of pieces and you can't do orders. You have to do hours of work. So I can show the solution that I put in another shop is working beautifully. And I'm big on visual management, so we got to be able to see the flow. We got to be able to see the problems to deal with them. Right picture here. Here we go. So you see these cards have numbers on them. So this board is a production board. So on the left-hand side is the operations that it goes through. It starts at the top and goes to the bottom. Cards move right in time, and we have a color system. So you work on black orders first, then red, then yellow, then green. The cards move down as they complete and to the right in time. But because each job has significantly different amount of work content, each card, so welding is our single point of control. Each card represents how many hours of weld that job takes. Each point is about 35 hours of welding time. So you see this 3 job is going to have about 100 hours of weld. This 1 job is going to have about 35 hours of weld. So the lead time for this 3 job is much different than this 1 job. And I got 2s. So I got 0.25, that's 0.25. I got 0 means it doesn't go through weld at all. And so our rule is we want to have, if you saw that other picture, stage for weld, we want 20 points. What's our tolerance? -0 plus 10. So you see they only have 12.75. So we're in danger of starving weld. And to be put to pre-weld operations, I want to have 40 -10 plus 10. Right now I have 28, so I'm still light on work. So what they do is they take the target minus is 80 minus the actual A plus B plus C. So I got 12.75 plus 11 plus 18. I add those up, subtract that from 80. My target is I need to release 35 points in the system to keep stable, to keep the inventory profile correct. So you see they're out of whack. They need to actually release 21 to get it back with the right amount of, without starving the system, the right amount of inventory. So what they do is they have a daily board meeting and they talk about this and say, okay, how much do we need to release? And then the back side of the board, which is here, is points that need to be released. So they'll put the job cards up here. This is late release, means it hasn't been started, but it's ready to go. And everything's managed off this board. So the impact of this for the company, we took their average daily or average monthly output from about 1.5 million to 3 million. So we doubled the output. We cut their lead time. Their backlog was about 15 million when we started with them. Now it's down to about 7. So we cut their lead time in half. Basically doubled their output and cut their lead time in half. Questions? Any comments?
I'll jump in and just say thanks for spending so much time on the call and walking through all of this. Always tremendous amount of information, not just to digest, but to potentially do something with. So it's not something that is easily understood, like simple, not easy, right? That's the best way to articulate all of this stuff. So thanks for taking us through it, and always love seeing what the results of it are, but simple, not easy. So, back to what Danielle said earlier, go back, take a rewatch through a lot of the different sections, but don't be afraid to reach out with questions, to Max, to myself, Joe, and any of the people that, kind of do this stuff on a regular basis. And don't feel bad if you feel like you're totally lost right now, because it's easy to feel that way and to be in that place, but we're all here to help. So
I know Diane went through it several times.
Yeah. Well,
It's
no, a few times, but no, one of the things I wanted to say was like for our weld shop, for our metal hoses, our inventory is certainly down, and I think when we started working with you, we were probably about 44% on time, and with one of our customers over the past probably like 8 months, we've been 100% on time, and our other customer we're at high 90s. And the reason we're not on time with that is because they supply us some parts. But yeah, it's been a tremendous change for our company. And I think after those first few months, it was tough for everyone to get on board. But once you start seeing the results, I mean, yeah, it had a massive impact. So yeah, it's been good.
Yeah, David, their president, he's like, so his whole, he goes, my whole career I've been focused on margin on jobs, and Max tells me it's not significant anymore. Like, we're not there to get margin on jobs. We're there to make profitability for the company. So sometimes our decisions are counter to what cost would tell us to do, but it's improving the throughput. So sometimes we'll have to do things to increase our cost to increase throughput. So our goal is not to reduce costs, it's to increase throughput at a faster rate than cost. The more I can make that separation, that's profitability. So sometimes we have to do things less efficient and take a cost increase to increase throughput at a faster rate. Again, that's a hard concept for people to understand.
Yeah, and we've been steadily hitting our sales goal since the beginning of the year, like our shipments out the door. So yeah, we're definitely noticing it on both sides.
Sometimes reminds me of the Seinfeld quote, if every instinct you've had is wrong, then the opposite would have to be right.
That's sometimes so great.
Sometimes we're doing the opposite.
Oh, that's a great one. What a great analogy.
I got a great story with Diane's company. So they're having trouble getting supplies for some of their components. And so what was happening was, they'd have this, it's like vendor said, oh, it's a 12-week lead time for the purchase order you sent us. It's a 12-week lead time, right? So they went back in their system and said, okay, it's a 12-week lead time. Well, what happens is that pushes the time fence out, says, well, for 12 weeks, the demand is what you had plus additional demand. So they sent it to the supplier and said, oh, if your lead time's 12 weeks, this is the new demand. So they look at the order like, well, for that order, it's a 14-week lead time for that size order. So then you put that back in the ERP system. It says, well, now I need a 14-week window to look at. So they send another purchase order for a higher quantity. And they're like, well, for that quantity, it's 16 weeks. And they get in this spiral of increasing the lead time because the time fence keeps getting bigger because the order's getting bigger. So I said to David, I said, no, go the opposite direction, go smaller quantities to the vendors. And I don't know, what was the impact of that, Diane?
We started getting partial shipments much sooner, and we were able to work on orders in process. Yeah,
So it's
it
like,
worked out.
Go smaller quantities orders. They're like, what? It's like, and David's like, I called the vendors and asked them for smaller quantities. They're like, yeah, we can ship that tomorrow. We have that in stock, but this huge order you want, right? That's going to take us weeks to do that.
Yep. No, it happened. And that now that's how we do it. We do it in, either it's here's a release, send us what you have, or smaller batches. So
Again, that's counterintuitive. Well, people are like, well, you know what logistics costs are going to do? Yep, our logistics costs are going to go up. But the question is our throughput going to go up at a faster rate than our logistics costs? If yes, do it. Right? So what I found is like optimizing one element of the system kills flow. So if you're trying to optimize freight costs, you're going to kill flow. If you're going to optimize efficiency, you're going to kill flow. If you're going to optimize, right, material utilization, you're going to kill flow. It's so hard, right? It's like, yes, we'll pay more for freight to get this stuff sooner so we can execute it, keep the total inventory down, turn our inventory, and increase our output. That's the system thinking, right? Not individual. Oh, we're going to, right? Purchasing, you need to keep your costs down. No, we need to keep the cost right size, but don't jeopardize throughput at the expense of cost. And I see it happen all the time. People are jeopardizing throughput at the expense of cost. So that's one of our main rules. Never hurt throughput for a cost reduction. Okay, that's all I have.
Thank you, guys.
Thanks, Max. Thanks, everybody.
Yeah, feel free to reach out to David or I if you have questions. I know, Diane, we're always in contact with you guys.
oh yeah.
Sometimes we have to do recalibration, but
Much appreciated.
Only when there's variability, Max.
right. Or they feel pressure to break the rules. Then they get a call. Okay. Thanks, everyone.
Thanks all.
Thanks.
Bye.
Have a great
And
day.
when I get this posted on YouTube, I'll send the link out to everybody.
Awesome.
Thank you.
Bye, everyone.